Very good evening, guys. How are you doing today?
Good evening, sir.
Okay. We were discussing the other day regarding the booster pump pressure for the fuel oil. Just give me a second. All right. So it's 750 bucks. One second. I'll show you. So when a fuel pump, I hope my screen is visible. Is my screen visible, guys?
Sir, it is still showing that you have started screen sharing, but yeah, it's visible now.
So when a fuel pump is injection timing, when a fuel pump in injection timing, the CCU sent to a signal to the PO wall. Then the hydraulic oil through Viva is supplying the fuel booster. The hydraulic piston and the fuel booster starts moving up, and the plunger and the fuel pump is upturned, that is, they start moving, and the pressure is reached about 750 bar. The fuel pressure reached and the fuel was injection pressure at the injector, and the high pressure fuel is injected, as the idea. And as set by the load RPM, the quantity is injected, and PY is controlled. And the hydraulic oil is released, means as per the PY control, it is stopped. Basically, the evacuation is low and hydraulic oil supply time is very short and plunger stroke is low. After injection, the fuel pump pressure is down to about 8 bar. 8 bar, why? Because it is a supply pump pressure. 8 bar. Alright. So 8 bar is almost the supply pump pressure, so it comes down to 8 bar. And the fuel pump suction valve open and the fuel fresh supply oil comes back inside the top of the cylinder. The वो sequence होता है. So just give me one second. So एक तो ये यहाँ पे मैंने देखा this is from some एमी इंजन ट्रेनिंग कोई मैंने निकाला था some time back. तो उसमें 750 बार दिया है. Then again now this is a comparison between MEC and MCC, the fuel wall timings. Okay. About the maximum pressure in the fuel of the MCC. So that is suggested to at 75% load comparison किया गया for both of the type of engines. It says over here about 580 or 540 bar something is for the MCC, and similarly what we have seen here, the peak pressure comes to around 750 bar for MEC.
Yes, yes.
So similarly a comparison हो गया इसका. I was also seeing whether one more chart also. This is about heat release. So this is your actual P comp and P max. ये आपका same MCC to MEC, same size. S7 S50 ME, 7 S50 MCC. So more amount of P max and P comp is also higher. So that's why P max is also higher. So about maximum इसका 120, 125 to 130 bar है. इसका around 155 bar, 160, 155, 150 bar ऐसा कुछ इसका maximum P max है. P comp is also higher. P comp is around at 110 or something. यहाँ पे P comp is about 124 or something. I maximum.
सर ये ओके ओके
You ask me, then I'll ask.
ओके सर, इसमें MEC में पी कॉम्प हाई रखने का क्या तरीका है, मतलब वेरिएबल एग्जॉस्ट क्लोजिंग से है या क्या है एग्जैक्टली?
design of the everything means you have your bigger Oris piston, you have your design of your liner. The liner is basically a little bit long, shorter, and your piston is downward. No? You have a little bit the more amount of the combustion volume is there. इसके वजह से ये बढ़ जाता है। एक और भी था उसका, डिस्कस विद समबडी, ये क्वेश्चन पूछते हैं ना कि हाउ डज एमईसी प्रोड्यूस मोर अमाउंट ऑफ पावर देन एमसीसी, ऐसा कुछ एक क्वेश्चन है। वंस अगेन डिस्कस विद समबडी। अंशुल, आप क्या पूछ रहे थे?
तो मैं ये पूछा था, इसमें मेरे को एमई इंजन में एक डाउट ये है कि जो एमई इंजन में फ्यूल पंप का जब जैसे अपना एमसीसी में स्पिल पोर्ट दिया रहता है, मतलब बाईपास हो जाता है जब, तो वैसे ही एमई में क्या दिया रहता है फ्यूल पंप में?
देयर इज इनसाइड इसमें है क्या, ये यहाँ पे एक सक्शन वॉल है, सक्शन वॉल। अच्छा, यू मीन टू स्टॉप द इंजेक्शन, यू आर सेइंग?
स्टॉप द इंजेक्शन तो वो तो हमारा प्रेशर नीचे बंद हो जाएगा, तो वो ड्रेन हो जाएगा, तो प्रेशर नहीं लगेगा।
LP will immediately depressurize, and immediately it comes down, and then the inlet comes to inlet pressure, and then it inlets, the suction valve opens because the pressure inside is lesser than the suction valve pressure. Okay, एक बार तब वो खुल जाता है। What is the question exactly? I didn't understand.
जैसे अपना इसमें रहता है ना, स्पिल पोर्ट खुल जाता है अपना एमई इंजन में, एमसी इंजन में,
LCC में
इसमें क्या रहता है, मतलब फ्यूल पंप में?
to cut out the fuel injection.
फ्यूल कट ऑफ तो हाँ, फ्यूल लेकिन कट ऑफ तो नीचे जो हाइड्रोलिक प्रेशर है उसकी वजह से हो रहा है, लेकिन जो अंदर इसमें जो ऑयल है वो स्पिल पोर्ट जैसा कुछ नहीं है ना इसमें?
नहीं, स्पिल पोर्ट देखो, ये है ना सक्शन वॉल है ना। See what you asking, how it is depressurizing?
यस सर।
देखो इसमें दिया है ना यहाँ पे। See, the fuel pressure reads the fuel injection pressure. The high pressure fuel oil is injected. Fuel quantity set by the ME RPM. The PIVA controlled the hydraulic oil release timing. The PIVA से वो hydraulic oil release timing होता है. The emission is hydraulic oil supply time is short and plunger stroke is low. After injection, the fuel pressure again comes down to 8 bar. You are seeing how this exactly comes down to 8 bar. ये इसका pressure गिरता कैसे? Okay, one second. See, there is no drain और ऐसा कुछ return इसका नहीं है, मतलब high pressure का removal ऐसा कुछ नहीं है. So what happens is, as soon as the plunger starts moving down, the what you call the volume which is there above into the high pressure pipe, that starts coming back into the pump, okay, into the plunger area. और फिर वो उसको वो pressure immediately falls below that. One second, there is something or not. One second.
बेसिकली जो प्लंजर नीचे आ रहा है वो अंदर वाले प्रेशर की वजह से ही आ रहा है ना नीचे?
कौन से वाले प्रेशर की वजह से?
फ्यूल का जो प्रेशर ऊपर लग रहा है वही उसको नीचे, प्लंजर को नीचे नीचे कर रहा है, पुश कर रहा है ना?
नहीं, ये नीचे इसलिए आ रहा है बिकॉज देयर इज नो ऑयल नाउ बिलो दिस। ये इमीडिएट
ऊपर से प्रेशर, यहाँ पर स्प्रिंग तो है नहीं, तो वो स्प्रिंग वाला काम तो फ्यूल प्रेशर है वही कर रहा है ना?
नहीं, फ्यूल प्रेशर एज वेल एज दिस, मतलब बेसिकली बोथ ऑफ देम आर बैलेंसिंग आउट ईच अदर. This being higher than this, it pressurizes down and all the oil comes out of here and immediately the pressure falls down.
Okay sir.
समझे? Because it is basically a seed system ऐसा, ठीक है? And this fuel plunger will open automatically if the line pressure inside the chamber falls below 8 bar. 8 bar से नीचे हो जाएगा तो suction valve खुल जाएगा. And normally वो suction valve खुला रहता है, only closes when the stroke happens. Stroke happens तो ये इसका pressure बढ़ जाएगा तो immediately वो spring से suction valve close कर देगा, ठीक है? That is the idea.
Okay sir.
एक मिनट
सर, एक और डाउट था। आपके जो कन्वेंशनल ये हेलिक्स स्क्रू वाले जो फ्यूल पंप्स होते हैं प्लंजर बैरल वाले, उसमें यू हैव अ नॉन रिटन वाल्व एट द टॉप टू मतलब टू काउंटरैक्ट द प्रेशर पल्सेस इन द हाई प्रेशर लाइन, राइट सर?
कौन सा नॉन रिटर्न वॉल्व की बात कर रहे हो? यू आर टॉकिंग,
ये सवाल मैंने आपसे पूछा था सर कि जैसे अपना हाइड्रोलिक इसका डीजल के डीजी के लाइन में ऊपर एक डिलीवरी वाल्व दिया रहता है,
ऑक्सिलरी इंजन के फ्यूल पंप की बात कर रहे हो?
हाँ हाँ.
हाँ ओके, हाँ देन यस यस, हाँ
तो
देन
व्हाट आई एम आस्किंग इज कि ऐसा इसमें भी कुछ प्रोविजन होता है क्या, लाइक अ नॉन रिटन वाल्व और डिलीवरी वाल्व और समथिंग लाइक दैट?
nothing like this directly over here, because यहाँ पे ये नॉन रिटर्न वॉल ये साइड पे ही है ना, ये ऑन द फ्यूल पंप साइड ये आपका नॉन रिटर्न वॉल है बेसिकली, जैसे पंप हो जाएगा टू नॉट अलाउ एनी फ्यूल पंप फ्लू टू गो बैक, ठीक है, बिकॉज वो जब तक वो प्रेशराइज रहेगा वो इट विल कम एंड डीप्रेशराइज इनसाइड द थियरी, ठीक है, दैट्स व्हाई यू हैव गॉट दोस एक्यूमुलेटर्स, ये एक्यूमुलेटर जो है ये वही काम करता है, जैसे वो नीचे जो करता है वो पल्सेशन को रुकता है, वरना वो जाके उसको हिट करेगा that way. तो मतलब देयर इज नथिंग ओवर हियर, देयर इज नो नो रिटर्न वॉल ओवर हियर, यहाँ पे एक आपका सक्शन वॉल ही है बस, देयर ओनली वन सक्शन वॉल, ठीक है, देयर इज नो रिटर्न वॉल ओवर हियर. एक सेकंड, आई हैड डिस्कस दिस विद समबडी, किससे डिस्कस किया था, कौन सा नाम था बंदे का, अभिजीत यार, अंशुल वो एक लड़का था ना अपना, नाम क्या है उसका यार, अभिषेक सिंह है, अभिषेक, हाँ अभिषेक सिंह, अभिषेक सिंह उससे मैं डिस्कस किया था. Just give me one second. There was one question that why uh, power developed in MCC or MEC is higher than the one second. I just check this. Uh, question ये था how MEP is increased from 18 to 19 bar MCC engine में. You guys have come across this question? Okay, how MEP is increased from 18 bar to 19 bar in MCC engine. Means MC और MCC के अंदर जब वो लोग ने कैलकुलेट किया है तो MEP is increased from 18 bar to 19 bar. इसका आंसर पता है आप लोग को?
नहीं सर.
सी आइडिया क्या है ना दैट इसका मैंने आंसर एक मिनट बनाया हुआ है, लेट मी जस्ट so this answer I got I think so from CC founder I believe, I don't remember, I think so maybe from founder. मैं एक बार उसको पढ़ रहा था तो उसने ये इसका मुझे याद है, and this chap had asked me this question. So you see here, this is the question. यहाँ पर नीचे वाला कि how your MVP is increased from 18 to 19 bar in MCC engines. So you see, mid-bore range 500, 600, 700 model was widened from 1996 and upgraded versions supplementing the existing 50 MC, 60 MD and 70 MC engines. So they upgrading जब किया तो इसको कर दिया MCC बना दिया, ठीक है, in 1996 and had stroke bore ratio that were raised from 3.82 to 4.28 to 1. And the increased power rating correspond to a rise in the mean effective pressure to 19. That is the reason why the MEP was increased from 18 bar to 19 bar in MCC engines. Okay. So also the rotating masses are also lower by about 25 tons or 13% of the 650 MCC, which yields benefit in reduced vibration excitations and also to be 100% balanced. Supporting the higher rating and modified turbocharging and stabilizer systems as well as modification of the combustion chamber configuration and bearings to be effectively operate the engine at higher load ratings. So main answer ये है कि the stroke bore ratio was increased from 3.8 to 4.21, okay, and the increased power ratings corresponded to rise in mean effective pressure to 19 bar. कहीं 18 बार था, अभी उसमें MCC में ऑटोमेटिकली 19 बार आ गया. एक क्वेश्चन पूछे ना कि हाउ डज द पावर इंक्रीज इन MCC, सब वो बोलते हैं कि इट इज अ कॉम्पैक्ट इंजन, इट इज the stroke bore ratio is larger, but kitna larger, that is this is the actual answer. Okay, 3.82 to 4.21, that was the gun. That's why the MEP increased from this thing to this thing. ये मेरे को किसी ने पूछा था long back. I think ये last week when he was giving me.
आज सर एक क्वेश्चन और पूछते हैं कि how MCC became shorter than MC. What changes they have done to make it shorter?
उसका आंसर ये है कि bed speed is below, okay, and the tire rods are shorter, and the total shorter means he's asking about the lifting height. कि engine का basically height जो है ना वो कम कैसे हो गया. तो अगर आप मैच टू मैच करेंगे ना, तो उसका जो बेड प्लेट है थोड़ा लोअर है, ठीक है. बेड प्लेट इज लोअर एंड द tie rod length is shorter. That means the entire entablature is actually shorter, ठीक है, because they made it basically a little bit more wider, this thing and design, and shorter in the height as well as width भी छोटा है. If you're talking about the entire length of the engine, means from 1, 2, 3, 4, 5, 6, वैसे छोटा कैसे हुआ है? Basically, each and every engine, what you call, bearing length and everything has been reduced. Means your journal length is reduced in the linear profile lengthwise also, as well as in case of your what you call height is also reduced because of that. So the bed plate being slightly shorter. एक मेरा फाइल है MC to MCC का हमारे ग्रुप में. अगर आप वो देखोगे ना, उसके अंदर एक ओवरराइटिंग एक फोटोग्राफ है इसमें.
उसमें केवल वो लेंथ दिखाया है, बोला है कि 1 मीटर कम है, बट वो क्यों है वो स्पेसिफिकली नहीं मेंशन है.
एक फोटोग्राफ है उसके अंदर जिसमें ओवरलैपिंग दोनों का, MCC और MCC का एक ओवरलैपिंग फोटोग्राफ है उनसे निकली होता है. There is one photograph which superimposes the MCC के and MC both of them. तो उसमें देखते हैं ना कि actually your bed plate is slightly lower, ठीक है. One second. over here. Configuration okay. तो देखना पड़ेगा कौन सा एग्जैक्टली. गिव मी अ सेकंड. मेनी ऑफ देम. So see, I'm talking about this. So MCC, you see, the entire bed plate is slightly shorter distance, ठीक है, थोड़ा छोटा है उससे. Actually, अगर ये फोटोग्राफ नहीं, everything is reduced in size. Means क्रॉसहेड को, bearing को भी नैरो कर दिया, क्रैंक पिन को भी नैरो कर दिया, मेन bearing को भी नैरो कर दिया. That is the reason it is length is reduced. And yeah, you see this. 520 meters is this, it is same. 1908 is the same. 1135 that is same. But one thing was this. Yeah, 1475 is this width है. 1575, 140, center of crankshaft. See here. MCC, the bed plate is slightly lower. Okay, we need to superimpose both of them. Slightly lower. The entire bed plate is slightly lower than the other one, and the entire entablature is shorter. Means आपका ये जो total height है ना, A frame का, तो A frame actually starts here. You see, A frame starts here. इसका A frame इधर चालू होता है. You see, the entire bed plate is smaller. Means the height of the bed plate is smaller than your MCC. Then your A frame starts a little bit lower. That's why it ends a little bit lower. That is the idea. So that is the reason it is bigger. You see this now? हाँ?
Yes sir.
ये देखो यहाँ पे ये है. ये आपका MCC का बेड प्लेट यहाँ पे खत्म होता है और A फ्रेम यहाँ पे चालू होता है, ठीक है. और ये वाला देखो यहाँ पे चालू होता है एडजस्ट. तो there is a distance about sometimes they increase the A frame little bit but reduce it below and you have shorter कर दिया थोड़ा सा. तो थोड़ा छोटा हो गया तो 1 मीटर तक उसका वो आपका सेविंग होगा और वो आपका width भी इसके वजह से कम हो गया. And twin stay bolt and this is also shorter stay bolt. हाँ, तो लाइनर भी देखो, लाइनर भी नीचे है. इसका MC का लाइनर थोड़ा ऊपर है, MCC का थोड़ा लाइनर नीचे है. It is come down. You see that? The liner is also below. So your top of your what do you call entablature top, that is also below. तो वो भी below है, तो लाइनर भी थोड़ा नीचे आ गया. That is the reason it is down. तो ये भी क्रॉसहेड भी थोड़ा लोग है स्ट्रेट फॉरवर्ड कर दिया, यूनिफॉर्म, नॉट द सेपरेट क्रॉसहेड विद द सेपरेट साइड. This file is there. It is called as HST MCC versus MC comparison.
Okay sir. Thank you sir.
What we are talking about? अच्छा वो फ्यूल प्रेशर का हो गया ना, कितना बूस्टर पंप का प्रेशर का है?
Yes, sir, yes, sir.
ओके. I was seeing today questions के अंदर केयूर, were you there when we had done propeller?
Yes, sir, yes, sir.
तो प्रोपेलर में वो मार्किंग वो सब देखा था हमने, राइट?
Right, right.
The rules and regulations. So I don't want to do that. Okay, what all is there marked on the propeller and what is marked on the actual body of it, and तो heat number भी होता है उसका और वो सब भी होता है. वो पूछते हैं ना, आज एक क्वेश्चन आया था, what is the markings on the propeller and what is the significance of it? तो significance वो इसलिए पूछा जा रहा है क्योंकि मतलब he knows to know that you know what a heat number is there. Okay. Now let's get back. Any other question before I start with the maneuvering section? चालू करते हैं. अच्छा, कल आई विल नॉट टेक अ क्लास, ठीक है? तो छुट्टी देते हैं, ईयर एंड है. अच्छा, आज क्या हुआ था सर की क्लास में?
आज उन्होंने सर रडर शुरू किया है.
रडर, ओके फाइन.
ही ऑल्सो आस्क कि रडर आपने लिया हुआ है. मैं बोला हाँ आपने लिया हुआ है रडर, वो लेकिन अनंत को चाहिए था तो उन्होंने स्टार्ट कर दिया.
क्या करना हमको? एयर स्टार्टिंग सिस्टम है, ये क्या कर रहे हैं? स्टार्टिंग सिस्टम्स. So yesterday we had understood about overlap and everything. Now let's talk about the components in the system today, where they are located and everything. Just give me a second. All right. So here we have, this is the starting a system components. Okay. All right. So design and operation details of various systems and everything, but basic functions in the system is actually same all makes sense. Okay. The main components: air receiver, automatic valve, automatic air starting valve, starting air distributor, and starting air hose. ये आपका main components in the system. So this is how they are located everywhere. Starting air receiver से आपका main है automatic air starting valve आएगा, ठीक है? Now this is just a lever just shown as a mechanical linkage, but actually ये automatic operation होता है इसका. Then you've got a slow turning valve also for that nowadays. Then you've got a non-return valve in the line, okay? And then the line is going to the individual, what you call the air starting valves. Because these are the individual air starting valves. There's a line in the line. There is a in the manifold. There is basically a flame traps over here and a safety valve with the end of the manifold. Okay. Now then one branch is coming here. There is a leak test valve. You can open this to test whether the valve is leaking or not. And then it's coming to a timing distributor, air starting distributor. And depending upon the position in which the particular air starting valve is there, which needs to be injecting, it will give the as a desired what do you call angular reference. It will give the signal for the pilot signal to activate the main air starting. Okay, that is the idea. And then the air starting valve will open. Now we'll see individually all these components one by one. Just give me a second. Okay. So next, now the rule says at least two receivers and with a pressure of 25 to 30 bar and sufficient capacity without replacement available for 6 starts for non-reversible engine and 12 starts for reversible engine. Now, our Ward sir asked the question very nicely that what is the maximum number of starts available for the engine? Okay, possible for my air starting model without actually replenishing the water. What is the answer for that?
सर क्वेश्चन क्या था, समझा नहीं सर.
Maximum number of starts possible for air starting without replenishing. What is the maximum number of starts possible without replenishing?
Maximum number of starts.
6 starts.
ये मिनिमम, ये स्टैंडर्ड रहेगा. So 6 starts are non-reversible and 12 starts for reversible. That is just your actual regulation. It says as per your soda. Okay. So what is the maximum number? Any idea? Or how to find it? How do you get the maximum number?
डिपेंड सर कि अभी लाइक कितना चाहिए रहता है स्टार्ट करने, कितना प्रेशर चाहिए रहता है.
Okay, but what will be the reference? Means there should be some reference, no? The max. How do I find out कि अगर मेरे पास एयर बॉटल में suppose 30 बार मेरा है चार्ज, फुल वॉल्यूम एयर बॉटल है, ठीक है, 100% वॉल्यूम इज चार्ज. So how much number of starts can be actually possible? ये 6 और 12 तो minimum requirement है. Just give me a second, I'll show you.
सर वो एयर बॉटल का वॉल्यूम पे डिपेंड करेगा.
Yes, that is there, but how will you know how many starts are possible? Right.
तो शुरू मतलब पूरा भरा है बॉटल तो ज्यादा पहले किक में ज्यादा प्रेशर खत्म होगा. वो जैसे जैसे बॉटल का प्रेशर कम होता जाएगा वो हर किक में ना कंजम्पशन कम होता जाएगा. तो कुछ इसका स्पेसिफिक नहीं है आई बिलीव.
नहीं है, हर इंजन का होता है. वन सेकंड, जस्ट ट्राइंग टू फाइंड. मेरा थोड़ा कंप्यूटर हैंग हो रहा है, जस्ट गिव मी. Just hold on, guys. Hold on. Yeah, sorry about that. थोड़ा computer hang हो गया था बीच में. So you see here, you have got something called as a main engine starting test. Now this is a main engine starting test. Is my screen visible?
ये क्या सर शॉप ट्रायल में होता है या सी ट्रायल में होता है ये
Yes,
डेटा?
C trial design.
ओके ओके
So they have the air starting in the sea trials. Okay. So capacity of the air water is 4 meter cube. Number one air reservoir is used. Number two is not used. One of the air reservoirs is used. So they are seeing the pressure in each start. How much is the thing. So 1, 2, 3, 4, 5, 6. They are able to get up to 13 starts in ahead and astern. Okay. And in the 14th start in the head, it is basically giving it, and in the 15th start, it does not. In the 14th start in the astern, it does not actually, you know, go into the astern thing. मतलब ahead में कर चुका है about 13 times. Okay. And the 14th time when they give it in the astern thinking, it did not work. Okay. So and this is the before and each after each start. ठीक है. तो ये आपका main engine global engine temperature control है ये. तो ये आपका idea है. So requirement is only 6 in ahead and astern and 12 for basically this thing. It goes up to 13 and 13 and basically 14 can be achieved. Okay. I have seen one more this thing like this. It's my 22 hand. Just give me a second. I'll show that also. एक और engine का.
तो ये एक्चुअली सी ट्रायल भी सर ये वाट सर का थोड़ा फेवरेट सब्जेक्ट है ये, इसमें भी काफी क्वेश्चंस पूछते हैं वो.
Yes, yes, yes. Sorry guys, I just got a call. Okay. So basically आपका ये air starting test का वो 22 वाला मेरे को मिल नहीं रहा है. I don't know where that this thing is. What question you think is there for this thing? अपना जो ये you saying that some what sort of questions है on C trial.
मेरे को थोड़ा देखना पड़ेगा सर, वो एक लिस्ट कंपाइल किया है उसमें देखना पड़ेगा, बट ही आस्क्स अ लॉट ऑफ क्वेश्चंस ऑन सी ट्रायल आल्सो. इसमें नहीं पूछेंगे ज्यादा मोटर्स में, बट सेफ्टी में वो सी ट्रायल वगैरह का पूछ लेते हैं.
अच्छा. Now this is the formula for the minimum starting air pressure for any engine. ये थोड़ा complicated formula है, but idea क्या है कि area of the combustion space and the height in that and the diameter into that and then some other what you call you got some constants. Okay. And the what you call the velocity of the engine and everything. तो उसको पकड़ के and what is the C is the constant depending upon the 2 stroke or 4 stroke उस पे एक कांस्टेंट आता है. तो इसके हिसाब से एक्चुअली डिसाइड किया व्हाट इज द मिनिमम स्टार्टिंग एयर प्रेशर रिक्वायर्ड टू स्टार्ट द इंजन. So basically, combustion area available, the height which is available for the entire stroke length, for the basically bore length, and then these are some other constants, and then your RPM which is going to be available, and the velocity of the what you call the when it is going to move from up to down, what is required, and then again one constant which is there regards to your friction and everything. उसके हिसाब से एक static constant होता है with regards to your two stroke, four stroke. ये भी एक फॉर्मूला है, बट जस्ट फॉर योर रेफरेंस, नोबडी इज गोइंग टू आस्क दिस, बट वो कभी पूछते हैं कभी कभी व्हाट्सएप के, हाउ डू यू डिसाइड व्हाट इज द मिनिमम प्रेशर एंड एवरीथिंग, ठीक है. अगर आपको कोई क्वेश्चन मिलता है व्हिच यू डू नॉट एबल टू दिस थिंग, सेंड इट अक्रॉस टू मी, देन वी कैन डिस्कस दैट, ठीक है. ऑलराइट, नाउ कमिंग बैक टू आवर दिस थिंग डिस्कशन. Just give me a second.
सर आप म्यूटेड है सर शायद.
Oh yes, yes. I'm sorry. This is your automatic air starting valve. I was saying this is a, we have done, we've seen this 6 and 12 starts, and maximum number of starts you have to see if you have to find out. You have to find by that by your system of your looking at your this thing जो आपका जो सी ट्रायल सिस्टम्स है उसके अंदर आपको रिपोर्ट मिलेगा. तो सी ट्रायल में देखेंगे ना आपको आपका आपका इंजन का भी मिल जाएगा कि अगर सी ट्रायल. So this maximum number of starts is available over there. So automatic valve is basically to supply air automatically for the starting of the engine. Quickly shut off the starting air when the engine is running on fuel, and for safe running, conserve the starting air. Basically, you don't want to waste the starting air. Okay. Normally, hand wheel is set to the automatic position, and emergency automatic valve can be operated manually. Must be locked and shut during maintenance prior engine running. तो इसमें बहुत सिंपल ऑपरेशन है. आइडिया क्या है कि इसका हैंडव्हील है, हैंडव्हील का एक ये उल्टा दिखाया हुआ, ठीक है. दिस इज बेसिकली shown like the air starting valve is on top, but many of the things we have seen is always I found the air starting valve to be down basically onto the ground. ये दिखाया on the top. So if you move this entire handwheel, it will go to the open position by manually opening, and first it will go to the auto position, and as you tighten the stem further down, it will go into the manually opening position to open the air starting. ठीक है. And ये indicator plate होता है जिसपे आपको मिल जाता है what is the actual condition. Okay. When you want to shut it, you have to move it the entire way outwards. One more difference I had seen where you had got a hand wheel with a small, a lever which had to be engaged, and then the trick wheel sort of a thing has to be moved, and that was moving horizontally. And instead of vertical like this, you got a horizontal operation. One side is completely automatic operation, one side is shut. And when you want to open it manually, you have to actually tighten it further, and that will open it into the manually open position. ठीक है. सो अभी इसमें ऑपरेशन कैसा है कि यहाँ पे आपका पिस्टन है which is your piston operated from one basically a solenoid spool valve. ठीक है. Solenoid spool valve is basically controlled by a solenoid. So the solenoid is basically controlling the operation of this thing, and it is giving the output to this chamber. Okay. So basically the compressed air is coming inside here from your air bottle. Okay. Now from there it is coming in here and it is going into this control valve. Okay. Now when your control valve is opened, okay, at that time when it is in the auto position, and the control valve is opened, then the automatic position will go down and it will pressurize this piston from top, and that will push this piston downwards to let the compressed air from here go to the starting air manifold and also to the distributor. That is the two flows. That is this From here, it is going to the distributor, one going to the starting air manifold. It is going to go like this. So one big line is going to the starting air manifold 30 bar, and one 30 bar line to the air starting distributor. It is like that. So when it is in the automatic position. As soon as the solenoid control is stopped, there is this operation which will go here, will stop, and the auto close signal will come, and it is draining out the air. And as the this thing happens, it will basically close the entire valve. Okay, so auto open, auto close, both by the solenoid valve system. Okay. Valve out is open, allowing the this thing, and the valve open is basically closing it. So this is your automatic air starting valve. It's like better diagram we have for 16 seconds. I had made one diagram of it. I'm not getting it. Just give me a second. मैं just going back to the manuals. मैंने एक manual से देख के एक diagram बनाया था इसका.
सर ये जो व्हील हैंडल टाइप का जो आपने अभी बताया, ये कौन से इंजन्स में होता है सर?
व्हील हैंडल वाला वाज इन द एक एमसीसी में देखा था मैंने, हॉरिजॉन्टल नीचे ऑन द फ्लोर बेसिकली, द फोटोग्राफ व्हिच आई शोड यू जस्ट नाउ, और
यस यस, द वन, ये जो डिजाइन आपने अभी दिखाया था इसमें
तो कॉमन
साइड।
है, मतलब कॉमन है जो ऑटोमेटिक एयर स्टार्टिंग वाल, ये ऐसा वाला टाइप का क्यों?
बिकॉज आई हैव नेवर सीन सच वाल सर, मैंने हमेशा वो बॉल वाल काइंड ऑफ अरेंजमेंट देखा है ऑटोमेटिक वाल्व्स में।
बॉल वॉल मतलब एक न्यूमेटिक हैंडल के साथ में एक वैसा कनेक्टेड ना?
राइट राइट।
हाँ वो वाला वही भी है, एंड दिस इज बिफोर दिस इज द मैकेनिकल वन। जो आप बोल रहे हो वो ये है, आई गॉट दैट फोटोग्राफ आल्सो, अभी मैं वही खोला था वो, दैट वाज दैट नॉट एक्सप्लेनिंग इट दैट नाइसली, दैट्स व्हाई आई डिड नॉट टॉक अबाउट दैट। ये जो आप बोल रहे हो इज जस्ट अ हाइड्रोलिक कनेक्शन एंड यू गॉट द, आई जस्ट शो यू व्हाट यू टॉकिंग अबाउट दिस वन। स्टार्टिंग मेन स्टार्टिंग, ये आप बात कर रहे हो ना, यू टॉकिंग अबाउट दिस,
यस यस यस
ये ऐसा वाला
यस यस।
wall with a arm and this thing. This is there in the MCC engine and everything. And this manual one is a very old design. Okay, automatic air starting one. My manual one is an older design where you had to do this. I have come across this in one or two ships, not very old ships, like maybe one was a, I think 2004 or 2006 built ship, and one was a 2008 built ship. It's not pretty old at the time when I joined it, but उसमें मैकेनिकल ऐसा एक हैंड व्हील था, ठीक है, तो यू हैड द मैनुअल कनेक्शन। ये तो आपका सिर्फ एक ऑटोमेटिक कनेक्शन है जिसमें आप ऑन ऑफ करेगा, तो ये एक ऐसे एक हाइड्रोलिक सिलेंडर से इसको ऑन ऑफ करेगा, ठीक है, एंड
राइट राइट।
दिस इज हाउ इट लुक्स फ्रॉम टॉप। You have got this one connection on top to actually manually open it if you want to open it. Otherwise, it is going in the automatic position. Idea वही है ना, इसमें भी वही है कि ऐसा है कि इसको आप ओपन कर सकते हो manually if you want. Otherwise, it's always in the automatic position. So automatically it is operating it by the stick. इसका ये वाला जो डायग्राम था ना, इसका एक मैंने बेटर डायग्राम खुद बनाया था, मतलब in a pen and paper and everything. I'm not finding that diagram. So that diagram had got very nice explanations. On the paper मिला है शायद, इसमें होगा। I made this all long back. तो मे बी इट मस्ट बी इन माय रिटर्न का नोट्स, मेरा जो रिटर्न का फाइल होगा ना उसमें कोई क्वेश्चन आया था। अच्छा हाँ, उसमें था राइट, ऑटोमेटिक एयर स्टार्टिंग वॉल का क्वेश्चन आया था लॉन्ग बैक, तो उसमें मैंने उसका डायग्राम बनाया। मैं कल निकाल के रखता हूँ मेरा रिटर्न का जो फाइल है ना, उसमें देखो, ये तो मैं सिर्फ ओरल्स का रखा हुआ है सब सामान, उसमें एक डायग्राम था अच्छा बनाया था। The principle is same, that you have got just one, nowadays you've got a ball wall and you've got operating in that way, and otherwise you have got this type of automatic wall. Okay, this is just the principle about it. Okay, now let's start about your starting a distributor. Let me just open the photographs. Just give me a second. Right. Starting a distributor. Now you have a cam connected to the starting a distributor. How is the starting a distributor cam connected to the camshaft? First of all, how many cams are there? That means what are different types of cams? Fuel cams and exhaust cams, right? How are they connected to the camshaft? What is the mode of connection?
Shrunk fit sir.
Shrunk fit, or there are three varieties. One is shrunk fit. One of them is what you call hydraulically mounted. Okay. मतलब शंक फिट तो आप बोलोगे आपने उसको थर्मली उसको ये करके किया ना, स्लाइड इन पोजीशन, so taking that, right?
Yes sir.
One was that. One was hydraulically mounting the cam into position, and last position is two parts of the cam. The cam itself is in two parts, and it is joined by basically nuts and bolts with a countersunk, and it is basically clamped onto the this thing, and there will be a keyway onto the cam basically. So if you want to replace it, that there is a replacement cam also which can be available, and you can do that for that.
इमरजेंसी के लिए रहता है ना जो टू पार्ट वाला है वो इमरजेंसी के लिए रहता है ना
इमरजेंसी के लिए रिप्लेसमेंट कैम के लिए होता है when you want to replace it. ठीक है. Some of them, some cams are always like this only. Like when some of the cam makers, no, they make this also like that. But if you want a replacement cam, then the replacement cam will be actually available in that two parts like this, and you can replace it onto the shaft. Okay. So three methods of mounting, as I was saying. One method of mounting is shrunk fit by thermally reducing increasing the the size, okay, and sliding it into position. Okay. Basically उसको shrink fit कर दो वहाँ पे. That is one method. And then like a second method is basically you hydraulically mounted. Basically you got hydraulic connections onto the cams, and you enlarge the bore by floating the entire this thing onto the camshaft and then sliding it into the position. That is the idea. Okay. And one more method is there, but the cam and camshaft is all one. So that basically it is forged together. That is one more type of design. But that is basically very small engines like your if you got a smaller 26 36 bore वाला engine है तो उसका camshaft ऐसे बनता है एक one piece में उसको solid बना है even your four stroke का वैसे बनता है. Nowadays they all have replaceable components. They want to replace everything, but one more method is basically solid foot camshaft with cams. Means everything is there. ठीक है. So idea क्या है? ये आपका starting a distributor है. Okay. This is a very rudimentary diagram. I have made one much more easier diagram than this. We'll see that diagram also. ठीक है. ये थोड़ा इतना easy नहीं समझता. Let's go to that diagram before, and then we'll come back to this because it will be easier to understand this. एक ये टाइप का स्टार्टिंग है डिस्ट्रीब्यूटर है जिसमें आपको it is called as a the cam is having only one type of a what you call profile. Nowadays what you have basically is one cam only that is having both the profiles, and there's some method to move the entire what you call cam follower. ये जो cam follower है उसको move करना है. That is the idea. So I just show you first the very basic one, then we'll come to what is the this one. Basically आपका जो basic idea with two separate cams, and then with one separate one cam only and the cam follower moving right. We'll discuss all the three designs. ये सबसे older design है where you had your cam follower and everything readily mounted around your engine. Okay, this is the first one. We'll understand this with a very very basic diagram. Just give me a second. Now, what diagram I've made is just for our reference. It is not something that is to scale or it is to scale to more or less, but it is not something which is you won't find it exactly in this type of design in your shell. Okay. Now, what you have here is first is a master wall which is having a 7-bar controller on the left side, and operating it will basically it is first venting out the air. As long as it is vented out, it is not giving the air in front. Then there is a master wall, and there are some interlocks that we will satisfy. We'll come to this interlocks in a bit. Okay, what exactly are these interlocks? Suppose the interlocks are satisfied, then the air goes up ahead. Okay, and this master wall is that automatic air setting. Okay, वही वाला master wall बोला हुआ, उसको automatic air setting बोला. ठीक है. Then sorry, automatic air setting और ये है master wall तो आपका वो जो kick वाला है, जो आपका जो hand lever है ना ये वो वाला है. ठीक है, जो आपका जो air starting kick देते हैं ये वो वाला है. Automatic air setting हो तो यहाँ पे. Now the interlocks, some interlocks need to be satisfied. We'll cover what they are in a bit. Then when the interlocks are satisfied, it comes into the top part of this air starting distributor. What you're seeing here is only one of the what you call control pistons. Okay, and this is the entire this piston is basically one of them, and radially they are arranged around your air starting what you call cam along like this. like we just saw the image before. We've got many of them. Here we are just seeing one. Okay. Now what is happening is the 7-bar control air is coming up here. Okay, on top of the balance piston. It is Did somebody say something? Okay. All right. Anant has just joined us. So the idea is when the engine is in the stop condition, at that time, this spring is going to pull the entire what you call air starting distributor piston up the cam. It is not even allowing it to touch the cam. All right. So basically, when the engine is operating at high RPM, this starting a distributor will not have this cam follow touching. Okay, it will be lifted up from there. Okay, that is one idea. Then when the 7-bar control air signal comes, it basically pushes the pistons downwards, and at that time it is not acting. The starting and distributor is not acting, but it's just pushing the what you call piston down onto the base circle. That means it is now getting on the base circle, and obviously the engine which is having the perfect time in where it is going to in the starting position, where it is going to be in the in the this part of the cam. It is basically going down in that area, and it is going to be in the starting position. That is the idea. ठीक है. अभी इस ये कैम का जो आपका जो starting a distributor cam है, your we will see in depth के इसका cam angle क्या है और what is the fuel pump cam का cam angle कितना है वो सब हम देखेंगे. But idea क्या है now? This is the idea that it comes and it touch on the base circle at least. Okay, and anyone with the stop position. Now, as the engine is whichever is in the start position, it will come here, and your this is the shown in the start position. Now, as soon as this happens in the start position, what happens is initially this vent is open, all right, and nothing is going onto the right side, not even going to on this side. So here, I don't know the pilot bar, 30 bar, nothing is going. Starting air wall is coming from the as soon as the automatic air starting wall is started. Okay, it will start giving the starting air, and it will come on the side of the starting air distributor. 30 bar is coming here. 30 bar is also coming from here to the side of the air starting wall. It is not activating the air starting wall. Okay, that is the idea, which we saw in that other line diagram also. Okay, but now what is happening is now when you want to start the engine, you have given the air kick and the one which is in the start position. This entire balance piston goes down, and the primary piston also goes down. As soon as that happens, this main 30 bar air will come from here, go from here, right on top of the pilot air signal in the air starting. And there is again a balance piston on this side, and there is a primary piston in that, and that will basically inject the air inside the engine. That is the idea. And once the air injection is done, your air engine will start turning. As soon as it turns, this cam will again come onto the onto this profile where it is not going to inject, and now it will be pushed up again that particular air starting distributor, and the injection will stop. Air starting injection will stop. Okay. So this diagram is only for explanation purposes. Is this understood? What is the operation of this automatic air starting distributor?
Yes, yes.
बेसिक वन. ठीक है, मतलब जैसे बेसिक वाला है कि जिसमें आपका एक प्रोफाइल है. यू माइट हैव टू सेपरेट कैम्स, यू माइट हैव टू सेपरेट प्रोफाइल्स फॉर एड एस्टर्न. उसका हमको कभी कभी टेंशन नहीं लेना है. ठीक है. Now we are just understanding how this operation works. ठीक है. As soon as the stopping engine starts in the higher RPM, when the higher RPM comes, okay, there is another signal coming on here which is not shown in this, which will again pull this basically cut off this master valve. And when that happens, again the spring will basically pull up this entire primary piston and balance piston upwards. It will vent all the air initially, and then the high pressure air will be vented, and now it will be again depressurized. The entire distributor will be depressurized, and the spring is going to lift it above from the profile of the can. It is not going to come onto the spring. Okay. So here you have got idea. Larger MC engines have got a radial distributor, which we just saw. Two cams at end of each camshaft. Means there is two cams, basically one cam in the forward, one cam in the aft at each end of the camshaft, and two radial distributors. Okay, basically 6 engines, 8 engines, 12 engines. You have got 12 units. You have got so 6 on each of them. Okay, then silver one cam surrounded by unit followers. One by unit holders. That is one cam. Man bender view. Each unit has an individual roller and cam for the old MC. Only one was there. Okay, that was the design which you just saw. One of the cams for that. Okay, this is the idea. This is just for explanation purposes. Is this understood, guys? I can go on to the actual line diagram and everything for this thing.
Yes, understood.
Yes, sir.
Okay, fine. So now this diagram can be drawn for your surveyor also when they want to ask you to explain it. Now let's go back to the sheet that we are understanding. Okay. Now you see this is the same design which is shown. This is basically the cam follower and the cam roller is basically around the cam, and one cam basically having 3 to 6 units. Now what you're seeing here is the what you call the actual the line going for the high pressure, and these are two pistons which you just saw, one balance piston and then primary piston. As it moves up and down, one side is venting and everything is not shown up here. Okay, and this is shown basically this line is coming from your one is coming from your main 30 bar air is coming here, and it is basically going to up and down, move up and down. Then this is the vent which is basically venting the from the center. Okay, this is a type of district. Circular disc with suitable ports, spool type valve readily around the central cam. Spool type valves laterally moved sliding camshaft. ये sliding camshaft क्या है हम लोग बाद में देखेंगे कि ahead astern principle whatever for the ahead astern what do you call profile of this thing. Now I talked about certain what do you call this thing, no? What do you call interlocks which were satisfied in that. So what interlocks are there? I'll just talk about it. Just give me a second. ये जो interlocks बता रहे थे, ये जो interlocks satisfy हो गए ना. So control air 7 bar shall be leading from the master valve. Okay. Once the master valve is activated, air shall be led to the auto air start valve, provided all the interlocks are satisfied. The following shall be interlocks: turning gear interlock, loop oil low pressure interlock, safety air interlock, camshaft lube oil low pressure where camshaft oil is there separate. If it is not system oil, then a separate camshaft oil is there, and then auxiliary blower interlock and reversing completed interlock only for manual. So these are the interlocks that need to be satisfied, and once the interlock is satisfied, then only the air will go to the starting air distributor. And then यहाँ पे बीच में मैंने slow turning valves दिखाया हुआ है कि this is the sensor for that, and this is the slow turning connection which is bypassing the automatic air starting valve and going directly from the slow turning line, activating it, and it is basically going it is opening the air start the slow turning. So what is the slow turning valve pressure? What is the difference between a main automatic opening and slow turning? What is there is a difference?
The difference is of the size of the lines that are connecting.
And
so basically there is less amount of air going in slow turning
so
as compared to your normal.
Less amount. What am I meaning?
Less amount is less pressure basically.
No. Pressure is same. That's what I wanted to say. Pressure उतना ही 30 bar ही है. But
नहीं, the volume is less. Yes, the volume is less.
Flow rate is less. Okay, flow rate is less. Okay, that is right. So guys make a difference of saying कि lesser pressure. No, the flow rate is less because the smaller lines is there. Okay, that is right. Now, when that the interlocks are fulfilled, the 30 bar air shall move from the air bottle pass to the automatic air starting valve and fill up the starting air manifold. Okay, as you see here, and with 30 bar air. Okay. Now, why is slow turning given? Is also a question asked.
This is to this is actually when the engine has been standstill for a long time.
Okay.
And it is to ensure that if there is any hydraulic locking, then in that case your engine components will not be damaged, because the amount of air passing through the slow turning valve is not sufficient to overcome the hydraulic locking.
But उसके लिए तो हमारे पास टर्निंग गियर भी है ना?
वो सर स्लो टर्निंग के बाद ना आरपीएम मेजर करता है, वो प्रॉपर आरपीएम आएगा तभी वो मेन एयर खोलेगा. और दूसरा ये है कि जो इंजन बंद रहते हैं ना फॉर अ लॉन्गर ड्यूरेशन, तो वो स्लो टर्निंग लाइक एवरी 24 आवर्स इट टर्न्स द इंजन.
Need not be every 24 hours. I don't know whether automatic के अंदर ही I have to confirm it from somewhere. Whether वो
few engines automatically turns and in few engines they don't. Like मेरे में नहीं था, but I have heard कि जो दूसरे फ्लीट के जो शिप थे उसमें वो ऑटोमेटिक टर्न करता था.
होता है सर, उसको आप ऑटो में रख सकते हैं या फिर आप मैन्युअली स्लो टर्न कर सकते हैं, वो एक ऑप्शन होता है.
ऑटो में जनरली आप उसको रखते हो तो फिर आपको यू नीड परमिशन फ्रॉम द ब्रिज एंड एवरीथिंग, नो, यू कांट जस्ट।
yes 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 yes
तो वो सी आइडिया क्या है ना, एक्चुअली इफ यू रीड द व्हाई द स्लो टर्निंग वाज प्रोवाइडेड, इट वाज प्रोवाइडेड इन lieu of the turning gear, where there was no turning gear on the engine to turn the engine. It was initially provided over there. Okay, okay,
ओके ओके सर, एक्चुअली ना आप मेन इंजन की बात कर रहे हैं, मैं जनरेटर की बात कर रहा हूँ।
okay, 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 okay. वो तो हाँ, then it's okay, then it's okay, ठीक है, then it's okay. वो तो automatic turning, हाँ, then it's okay. Now slow turn is given to avoid excess torque to the unit because of the hydraulic work, as you said. Okay. Uh, Sometimes, you know, before, when you are starting the engine on what you call some loaded program, okay, automatically before starting the engine on air, it will give a slow turning signal, and once the slow turning is satisfied, then only the engine will actually turn on air. ऐसा भी एक कई engines के अंदर है, so you got a slow turning which is automatically incorporated. Okay. Now also the 7-bar air which is going up here, okay, 7-bar air is led through the pressed master valve, shall lead to the inlet part of the balancing chamber. Okay, balancing chamber. Okay, the starting and distributor. And one unit which has the starting cam in the start position is here. Okay, that unit shall that be pressed down and act upon the piston, and the balancing chamber shall be disrupted. So that will basically come down. And note, the cam or distributor shall have to lie on the negative part of the cam for it to be in the start position. Okay. For the distributor on the start position, the balancing piston shall move downwards and shall cause the closing of the vent line. So सबसे पहला vent line बंद होगा, okay, and uh, and then one at the same time the primary valve on the distributor shall move downwards and allow the 30 bar air to come inside. मतलब पहले vent बंद होगा और फिर आपका ये आपका main air आता है यहाँ पे 30 bar, ठीक है, from the manifold to the starting air distributor, ठीक है. Now upon entering the distributor, this 30 bar air which will now be called as pilot air exiting the distributor is moving from here to the manifold led to the starting air from the to the starting air wall of that particular. So now only it is going to be called as pilot air, not before it is exiting the starting air distributor. Okay, at the same time, starting air wall, the pilot air shall open the wall and cause the 30 bar to move the manifold down and inject the starting air wall. Okay. Now, as soon as the engine shall start to turn, the engine shall rotate at the same time, and starting cam shall move to the stop position, as you see here. And as that happens, the roller shall rest upon the base surface and shall cause the relative upward movement of the starting air distributor. Okay, and end the in air injection to that. In the meanwhile, some other unit shall come into the starting position again, and that is so on and so forth. Like this, the air shall continuously be injected to different units until the engine shall approach the sufficient RPM for the fuel to be injected. Okay. Note, a negative cam is specifically provided for the air starting distributor, irrespective of engine maker. Why? Why you always have a negative cam for starting a distributor? Irrespective of engine maker. Fuel cams में different है, ठीक है. Fuel cam में थोड़ा सा shape different है, but all the makers are having a negative cam. Why? See, it is there because the only negative cam shall always ensure that this wall shall close positively. That means the negative cam is a cam where the roller shall travel below the base circle. So that means as it comes onto the base circle, it will close. That is the idea you want. Not, you doesn't want that to go into the negative part of it and it will close at that time, because you want to do that. That is that. ये इसमें एक shut off valve भी दिया हुआ है in case you want to do any maintenance. ये shut off valve again. Now let's go back to that idea of. Right. Now, if I talk about number of cams and everything, no, so you have to understand that different engines have different mechanisms to uh, provide for their starting and reversing. Okay. So when we talk about reversing, we'll talk about number of cams and everything, but we'll again touch base on that again on that thing. Okay, when we talk about reversing. अभी हम लोग सिर्फ स्टार्टिंग की बात कर रहे हैं, रिवर्सिंग पे अभी हम लोग पहुंचे नहीं. So there is a idea about turning a camshaft relation to crankshaft, or turning the cam on camshaft, or turning a ruler point of contact or something. We'll come to that when we talk about resistance. Okay. Now the idea is that starting a distributor is a very basic one. There is a negative cam distributor cam. Now you see this is again one starting a distributor where you have the same signal what you're seeing. Now air starting signal is coming here and pilot valve to and form the air starting valve is a vent. All right. And ahead profile and external profile. So basically idea kya hai? Here you have got two separate profiles on the cam and the air starting distributor will be stagnant and the entire camshaft will move horizontally from ahead of the external profile. We'll see that how it happens later. Okay. But idea क्या है दो profile दिखाए तो I just thought I'll talk about it. Okay. So the negative part is basically this part which you have here. The black part is the negative part, and base circle is the entire is the upper one. So as it's on the negative onto the base circle, the vent line is open and the pilot line is depressurized. As soon as it comes onto the base circle, the air goes from here, goes into here, and now the vent valve is closed. That is right, as we saw this one. And that is basically allowing the air to go inside the pilot line, 30 bar air. And this is the spring which is holding it up here. Now return spring holds the stand clear during the normal run, as I said. Normal run. Now this is the starting air distributor again for a different engine showing the entire same thing. जो हमने ये वाला देखा ना इसी का sectional view है ये showing the distributor cam and the cam is now you see different shape but again a negative cam. Okay. And there is initially some clearance and then it comes down to the base circle and it moves, it comes into the starting position and it moves down and then you got the air connection to the atmosphere through silencer, they are closed and it is the air going into the starting. And the vent is basically the starting. And a common pilot line is center line. Yeah, earlier as well. Now, nowadays, the starting air distributor is somewhat different. So earlier, what was happening is that your entire starting air distributor was just going up and down, irrespective of the. It was just following the cam follower. ठीक है? मतलब वो आपको cam का ruler को follow कर रहा था. It was just following the entire motion, and irrespective whether you are having ahead profile, astern profile, it is not bother about. Okay? Nowadays, you have got a different design. Just give me a second. Am I still audible, guys?
Yes, yes, sir.
Oh no,
Yes, sir.
my screen is just frozen. This can yeah, there it is. So the idea is nowadays this is the sorry one second. This is the earlier starting air distributor. This is the one which is nowadays in an NCC engine. Okay, this type of arrangement is there. We will talk about what this is exactly. Nowadays you have got something like this. Let me just zoom in on this. So they have made the distributor little bit, you could say, a smart distributor. Okay, instead of having just a vertical movement of the piston, of the piston going down, following the air signal and the spring which is holding it up. Now what they have done, they have given two profiles itself for ahead and astern on the same cam. What they have done is basically I show you a three-dimensional photograph of this entire thing, and it will become better. So here we have MCC starting air distributor. So you see what they have done. What they have done is that they have made one profile for a head, which is the inner profile, and a outer profile for estern. So basically, they've cut two profiles, and you are having the cam follower and the cam roller to basically articulate between that. And what you are doing is at one time the when the starting air distributor is acting fully down, it will rest on the ahead profile, and when the starting air distributor is slightly up, okay, slightly up, it will rest on the estern profile. That was the idea. That means in the middle position, it will not rest on either ahead or estern, and that was the idea which was it was made. Okay, this is your MCC starting air distributor. So the idea is that they made this design possible. Okay, and we will just go back to the sheet. We will basically explain what I was trying to say. So here you see, here you have here you have got the entire starting air distributor, the roller and the follower. This is a follower, which is going to basically rest on one of the faces. So one of the inner one is the ahead face, and outer one is the astern face. So depending upon the operation, you have a starting air signal for ahead, a starting air signal for astern. Okay, and initially it is not going to touch both of them, so it is not going to be having either astern or ahead in the middle. Okay, so depending upon that, the spring is going to pull this entire thing in the middle, not going to touch ahead or astern. As you require it, it is going to come down, and if it goes in the ahead signal, it is going to go fully down. The astern signal, it is going to be slightly up. Okay, so you see the head signal now it is touching the lower profile. Okay, and now if you're coming in the astern signal, it will touch the upper profile. That means the signal for the head and astern signal, which is coming for the starting, is having a different what you call control. And then your pilot air signal वो सब तो वही है. मतलब air starting और pilot air signal तो exactly वही चीज है. But now what is happening is main air is coming into different profiles instead of having the main air coming like from one side as you saw here, like main air coming from what you call air starting signal coming from one area. Now you've got two separate sides, one up and one below, and that was what is made. They made the distributor basically a little bit smart, and they did that, and so that now you do not have to have two separate cams. Basically, you can have the reversal of your engine decided independently. It does not require a separate third-party system to move the entire camshaft or anything. You just have to move the cam follower to the ahead or astern profile. Okay, that was done. So this is the idea followed for reverse. We will come on reversing. We again touch base on this. But when you're talking about the air starting distributor, you have to talk about this type of distributor also, where you have a distributor which is having little bit two separate signals, one starting air ahead and starting air astern. That is the idea. So that basically the signal is going to come from wherever your control system is giving that signal, it is going to come from there. Okay, whether ahead or astern signal. Okay. Just give me a second. All right. So this is the idea. Is this understood? The starting air distributor, which is on the MCC engine, and the earlier MC engine starting air distributor was very simple. Okay, just nothing having any profile, one profile, and you had basically some method to move the entire camshaft. You see that? Okay, ये ठीक है ना?
Yes, sir.
Okay. Now you have got the starting air. Okay. Now starting air wall के अंदर सब questions पूछते हैं. ठीक है. We first understand the components of the starting air wall. एक ये तो ऐसे ही just a line diagram. This is the actual sectional view, and I have got one photograph view which is actually showing the exact what different parts. अभी कैसा आएगा? Fitted in each cylinder. Timing of the opening and closing is controlled by cam, as we saw. Balance piston is there, okay, over here, and you have got an opening piston over here, and you've got spring for closing. All right. So balance piston and valve head are of the same nominal diameter. If you see, valve head and balance piston are the same nominal diameter. All right. In order to hold the valve in balance when the air is open. So what does this do? How does this maintain balance? what is talking about? See, idea kya hai, when you want to open it, the 30 bar is coming here, pilot signal, and that 30 bar is going to act on a larger area. Then this basically operating piston of the valve head. So here 30 bar is coming over here, and it is 130 bar is going up and 130 bar is opening down. So it is keeping this entire system enclosed and it is in balance. Now the balance will be disrupted as soon as this external force comes here from the pilot air, and now this air is at a larger diameter, and instantly it will compress the spring, and now it will disrupt this balance. As this force is higher than this force, it will open the starting air. Now, as soon as that happens, the main air will start going inside the engine. And what is this balance piston? What is the purpose of it? How does it hold it in balance? क्या करता है?
So basically, बैलेंसिंग पिस्टन पे आपका जो मेन लाइन का एयर है वो एक्ट कर रहा है, एंड इट इज आल्सो एक्टिंग ऑन द फेस ऑफ द वाल्व बिलो. तो बेसिकली दोनों का एरिया सेम है, so it will keep it in the closed position.
But how it in the open position is helping? That's what I'm asking.
So opening में तो ये हो रहा है कि सर because आपका जो मेन लाइन का जो एयर है उसकी वजह से बैलेंस है, तो जो इम्बैलेंस कॉज हो रहा है वो आपका पायलट एयर की वजह से हो रहा है. तो एक एक्सटर्नल फोर्स लगेगा ऊपर से. नीचे वाला तो बैलेंस है, बट ऊपर वाले की वजह से थोड़ा इम्बैलेंस होगा, एक एक्स्ट्रा एडिशनल फोर्स आएगा which will push it down.
That is okay. That is okay. But how does this balance piston help in closing or keeping it open? Is my question. ये WhatsApp का क्वेश्चन है, मेरे को पूछा था मेरे ओरल के अंदर, ठीक है, कि how does it maintain the valve when the valve is open? How does it help? See, what happens is when the valve opens, okay, when the valve opens, ये balance piston slides down. The actual photograph ये है balance piston, and this is your inlet line for this thing, okay? So what it actually does is that it comes into the opening line of this main air line, okay? तो इसको थोड़ा बहुत throttle करता है, ठीक है, वो throttle करता है, and that becomes little bit like a, you know, it pushes the air further down, okay, and it basically throttles the air inlet over here. Then as soon as the air is basically cut off from here, the closing piston closes it. But what happens is, if this balance piston is not there, suppose the balance piston is larger or is the same size as this, but the balance piston is not there. So पहली बात तो how will you see these two separate components? ऐसा बात वो हो गया. Then what will happen is, as soon as it closes, no, there will be basically an imbalance caused because of what happens is you will have some pulsations as the valve closes against the spring. The valve might want to open again, but as soon as it closes fully, the balance piston again will maintain that internal balance, and as the valve is closing also, it will start having that effect of opening the main air inlet line further and closing this valve further. Closing जैसा होता रहेगा, ये धीरे धीरे बैलेंस आता रहेगा, ताकि जैसे ही बंद हो जाएगा, it will not open again. This is the idea, to prevent it again from opening again. Because basically what happens is the spring is losing its what they call tension over a particular time. Then what will happen, it might, you know, not give adequate tension, and you might get a slapping effect where the wall goes up and it might want to come down again because of inertia. So it will prevent that from happening. That is the idea. So जैसे ही वो होता है, ये पहला क्या करता है, जब ये नीचे आता है तो ये थोड़ा मेन एयर इनलेट को throttle करता है. This is actually given the answer by WhatsApp only after my oil, when he did not pass me in one function. So I asked him, sir, what is this thing? So he explained it to me like this, that this is it. So he said that it throttles the inlet line air that way, and then basically after that, once it does that, and closing also, at the time of closing, the spring force, whether it is not there also, this will basically overcome this. There is no pressure over here, so this balance piston will धीरे धीरे इस wall को वापस बंद कर देगा. Even if your spring is basically broken or anything, again the wall will close, because initially there will be some force acting on here and lesser escaping air from here, and slowly then the valve will close, but still the valve will close. So he asked me as saying that the spring holds the valve closed, but if the spring is broken, then what will happen? So he said that idea is that if the spring even breaks in service, open कर दिया by the air, close हो जाएगा, but close होते होगा तो वो धीरे time लगाएगा, and then afterwards it will close, and because of the balancing piston, it will maintain that balance in the start position, and it will close it as there is no the force opposing it and to open it. That is the idea, and वही idea. ठीक है, that is the idea, and that is the reason why it is provided. Now one more thing is there, that he asks what are the type of sealings over here. What are the type of sealings? ये बैलेंस पिस्टन के अंदर यहाँ पे क्या टाइप का सीलिंग होता है और यहाँ पे ऑपरेटिंग पिस्टन में क्या टाइप का सीलिंग होता
बैलेंस पिस्टन में कोई सीलिंग रिंग नहीं होता सर.
है? एग्जैक्टली. इट इज बेसिकली अ वेरी गुड मेटल टू मेटल कॉन्टैक्ट. ठीक है, पॉलिश्ड. ठीक है, और यहाँ पे
ओरिंग होता है.
यहाँ पे एक टेफलॉन का ओरिंग है. ठीक है, टेफलॉन ओरिंग है. अगेन देयर इज वन मोर ओरिंग व्हिच ही इज नॉट टॉकिंग अबाउट इन द एक्चुअल डायग्राम कि यहाँ पे जब ये जो बैलेंस पिस्टन लैंड करता है ना ऊपर, ठीक है, वहां पे एक गैस्केट टाइप का रहता है व्हिच इज सीलिंग द opening and closing of the thing. ठीक है, once it is operating that doesn't happen, but once it is in the closed position, ये जो एयर चेंबर है इसके नीचे को वो सील करके रखता है. ठीक है, that it does. ठीक है, I will show you the photograph of that sectional view. इसमें दिया हुआ है इसमें. This is talking about talking about right on top of the upper edge of the balance piston where it is going into the cover. यहाँ पे एक ओरिंग होता है. ये 15 नंबर जो दिया हुआ है ना यहाँ पे, ये 15 नंबर उसका दिखा रहा है. It is going basically around. It is not shown in this side. Basically, it is there in the step which is there. यहाँ पे बोल्ट है उसको टाइट करने के लिए वहाँ पे उसका एक ओरिंग होता है.
सर आई थिंक एक वॉशर होता है यहाँ पे.
वॉशर ऑन दिस थिंग.
यस सर.
15 नंबर क्या है? गैस गैस्केट बोल रहा है. ठीक है, वही गैस्केट बोल रहा है. ठीक है, एक गैस्केट है. ठीक है, गैस्केट है. And then there is one on the body outwards where it is going into the this thing. There is this thing, and then there's no nothing over here. You see, nothing on the balance system. And यहाँ पे टेफलॉन का रिंग होता है, बट यहाँ पे दिखाया नहीं है इसमें. यहाँ पे भी इसमें भी नहीं है. In this type of this is for MCC starting here. इसमें कुछ भी नहीं है. यहाँ पे कुछ नहीं है, यहाँ पे भी कुछ नहीं दिखाया हुआ. So I have seen one with where you got Teflon ring over here. यहाँ पे भी वही आइडिया है of the labyrinth principle. ठीक है, बेसिकली बेसिक आइडिया जो आपका labyrinth principle इधर भी वही आइडिया. ठीक है, and so
सर यहाँ पे भी बोल सकते हैं ना, अगर वाट सर पूछते हैं कि और लैब्रिंथ कहाँ और यूज होता है.
ये भी बोल सकते, but don't use this because he did not use the word labyrinth. वो
ओके ओके.
मतलब ये मैं आइडिया बता रहा हूँ. बट सी labyrinth में कैसा होता है ना, रिड्यूसिंग.
इसमें स्लॉट्स होते हैं सर बेसिकली इसके जो.
इसमें स्लॉट नहीं, इसमें स्लॉट नहीं.
नहीं बहुत फाइन कम डेप्थ वाले स्लॉट्स होते हैं सर. एज फार एज आई रिमेम्बर मैंने जब ओवरऑल किया था तो आई हैड सीन.
I mean slot मतलब there is no opening in the slot.
नहीं 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 ओपनिंग नहीं है सर. इट्स जस्ट दैट
यहाँ पे है ना स्लॉट, ये दिख रहा है देखो, ये स्लॉट दिख रहा है, ये दिख रहा है, यहाँ पे भी दिख रहा है, कट दिख रहा है. वो उसके स्टेप्स बने हुए हैं, बट देयर इज नो ओपनिंग टू इट. लैबिरिंथ प्रिंसिपल में कैसा होता है कि देयर इज ओपनिंग अक्रॉस इट एंड अलाउइंग द रिड्यूसिंग प्रेशर. यहाँ पे तो रिड्यूसिंग प्रेशर का बात ही नहीं है ना. यहाँ पे तो प्रेशर जा ही नहीं रहा है अक्रॉस इट. दैट इज आइडिया. मतलब इट इज नॉट कनेक्टिंग. मतलब जैसे आपका पिस्टन रिंग्स के अंदर कनेक्शन है ना, अक्रॉस द ओपन एंड ऑफ द पिस्टन रिंग्स, द ओपन ओल्ड टाइप, जो एस कैप वाला था और जो आपका जो ऑब्लिक कट वाला था पिस्टन रिंग उसके अंदर. तो वो लैबिरिंथ प्रिंसिपल ये व्हाट यू आर एक्सप्लेनिंग. यहाँ पे वो लैबिरिंथ प्रिंसिपल नहीं है, जस्ट मिसस्पोक. यहाँ पे लैबिरिंथ नहीं है बिकॉज लैबिरिंथ में तो वो आपको रिड्यूसिंग प्रेशर का बात है. यहाँ पे रिड्यूसिंग प्रेशर का बात ही नहीं है. यहाँ पे मेटल टू मेटल कॉन्टैक्ट की वजह से देयर इज अ वेरी नाइस दिस थिंग. एक गैस्केट यहाँ पे भी होता है इसके एट द माउथ ऑफ द दिस थिंग where it go into the cylinder head. Alright. Now let's talk about ये आपका स्टार्टिंग का सिस्टम हो गया. Now let us just talk about quickly about the flow-through system, just to show the reversing part. Okay. Now, when I say reversing, there are some means to reverse. Okay. What are the different means to reverse an engine? How do you reverse an engine? Specifically, if I say what was the method of reversing for MAN BMW and what is the method of reversing for your Sulzer, if I say Sulzer or say Mitsubishi, what are the means for reversing? How do they reverse the engine?
सर्जर में सर वो पूरा कैम ही रिवर्स होता है और मैन बीएमडब्ल्यू में वो कैम गाइड को पोजीशन चेंज करता है.
ओके, तो एक काम कीजिए, जस्ट यू गाइस, आई होप यू आर नोटिंग इट डाउन. तो एक लिखिए, एक ये है, क्या बोलते हैं, एक आई थिंक आई हैड अ फोटोग्राफ ऑफ दिस आल्सो. Just hold on one second. All right. So I just took a photograph from my notes. So this I just made a understanding of different methods of reversing, because before going into the line diagrams and the methods, we should understand what is the method for reversing for different engines. So you see, I've just written out reversing methods. So there was two ideas. One is that one cam for ahead and astern. Okay. And the other idea is two separate cams with the axial shift of the cam or camshaft. So basically, reversing method is one cam for ahead and astern, or two axial cams for ahead and astern for cam and camshaft. Now, for Sulzer RTA up to RLB RTA, okay, they used to use turning the camshaft relation to the crankshaft idea. And then Sulzer RTA only fuel pump, they were using turning cam or camshaft individually. That means cam was turned or cam was turned individually for the fuel pump. And similarly for man BMW fuel pump, all right, they were shifting the roller point of contact. That was the idea. Okay. Then when you had two separate cams, action shift in the gear shift, action shift of cam or camshaft, they were used by BMW engine for the starting air distribution, and similarly used for the Mitsubishi fuel pump. Okay, this is the entire idea of the three different engines, Mitsubishi, Sulzer, and BMW. All of them are utilizing either or of this type of a requirement. Either one cam for ahead and astern So that is up for RID, RPA, everything was the cam and camshaft for the fuel pump and starting a distributor. Both had to be reversed for this thing by turning the camshaft rotation to crankshaft. How was this done? By your lost motion clutch. Okay. Camshaft rotation to crankshaft. So basically camshaft was shifting actually and it was turning the entire this thing. Then further RTA fuel pump only was using turning the cam of camshaft again by a lost motion clutch, but now that was only controlling the fuel pump cams. Starting a distributor was done by a separate by a vertical shifting of the this thing. Yeah. ये horizontal shifting था वो vertical shifting and then shifting a roller point of contact was done by B&W fuel pump किया गया था and then actual two cams you have actual shift of the camshaft you're utilizing a man B&W starting at distributor which you just saw okay the entire uh, this thing is moving the entire camshaft is moving or in the latest one which you are seeing is what you saw that the entire distributor is only moving the follower वही बात है ना या तो follower को move करो regular को move करो या आपके cam को and then Mitsubishi fuel pump is also using the same type of method. Okay. That is right. Yeah. Now this idea is followed by almost all makers of the engine. Now, as I talked about reversing, what is a cam that need not be reversed and why? You have your fuel, exhaust, and your starting air cams, right?
The lubricator cam need not be reversed.
Exhaust, sir. Exhaust वाला नहीं होता है.
Lubricator need not be reversed. Okay, lubricator cam को तो मैंने consider ही नहीं किया ठीक है उसको भी आपने reverse नहीं किया है and your exhaust cam.
Exhaust, yes.
Exhaust cam. So mainly I was talking about exhaust cam. Why exhaust cam need not be reversed? Is it symmetrical or asymmetrical?
Symmetrical, sir. और मतलब दोनों प्रोफाइल में almost same ही एंगल है उसमें.
It is not exactly symmetrical. About 5 degrees का फर्क है in the S-turn. ठीक है? Generally, like something like opens at 65 before BDC and shuts at 50 after BDC. For S-turn ahead running के लिए 50 degrees before BDC and shutting at 65 degrees after BDC of your for ahead running. S-turn में उल्टा होगा. 65 before BDC opens and shuts at this time. So timing has been changed in S-turn movement, but no reversing is carried out. This is because it is acceptable. Because your S-turn running के लिए आप ज़्यादा run नहीं करते. You're not running permanently for S-turn running. So it is not a symmetrical cam, and even if it is not a symmetrical cam, because we are running only S-turn for a very short while, you are not going to be, reversing this cam. Otherwise, all the other cams need to be reversed. And when you are reversing the air starting, you are also reversing the firing order. You are also reversing the way the direction of the engine changes. Okay, that is the idea. So firing order is also changed as you start your in ahead or S-turn movement. That is the idea. Now let us just see go through of a system to understand whether the what we have understood about the entire operation system. We will be concentrating on man point of view first, and then we will be understanding the loss motion clutch and everything, and we'll buy it. पहले हम लोग जब ये man point of view का समझ लेते हैं, and now what we are seeing is a very rudimentary design and very basic design showing the entire starting air system. What you have here is a starting air system for say a MCC engine, all right, and this is a very rudimentary design. The components which are shown here are the main air vessel. This is the what they are showing as the pilot valve is basically the actual while to operate that automatic air starting valve बताया ना एक pilot valve spool valve था जो operate करता था mechanically पहले operate करता था बाद में आजकल इसको solenoid से कर दिया आजकल इसको replace करके एक pneumatic cylinder से कर दिया which opens and closes that valve. Okay, but this is just a basic idea that we have. Okay. So, and then you have got the lever which is going on fuel and air, and then you've got the automatic air starting valve here. Here you've got a turning gear and the turning gear interlock. Here you've got a starting air distributor. All right. Here you've got a starting air distributor, and here you've got the main air starting valve. Okay, main air starting valve on number 4. Okay. Now cylinder number 4 is what is in the starting position at this one. That's why they're doing this one. Now what happens is, in this position, main air starting wall is closed, so nothing is going. There is no air coming to the pilot wall, no air going to the automatic air starting wall, and no air going to the turning gear interlock also. Nothing is going. Okay. Now suppose I open the air starting wall. Before that, here the turning gear is engaged. As you see here, I have to first disengage the turning gear. Until I disengage the turning gear, there is a micro switch which will always give the turning gear interlock and it will not allow the air to proceed. So now what they are showing here in the mechanical representation is a manner is if you open the air wall, what will happen here is that your air will not be allowed to go ahead as long as turning gear is engaged. So as you see, as the turning gear is engaged, this air is going to be blocked up here, not going to air. Basically, the satisfaction of the interlock is not going to happen. But what happens nowadays is not something like this. You have not a wall with opening closing. You have a solenoid wall and a micro switch, which is basically not allowing the air to go in. It is basically not allowing the satisfaction of the system to go in. So interlock जब तक satisfy नहीं होगा तब तक आगे नहीं बढ़ेगा. Now you're turning your interlock is see the change of the air. This is earlier a dotted line. Now it becomes a fully line. That means the air it is opening. If it can go right up to the automatic air starting. All right. Now the everything is ready. Now you can start the air. Now I give the air kick by pushing this lever down, and as soon as that happens, the main air starting wall air comes here. I open this line, it's not shown, I open later on also. It is always shown shut. Don't forget about that. Now air comes here, and initially the pilot wall will bend, and then the air goes up here, right on top of the automatic air starting wall. At the same time, turning air interlock is satisfied, and it will allow the main air to come here, 30 bar to come here. Okay, as soon as it occurs, now your pilot valve is basically going to be depressurized. Okay, because this valve is going down. So you see there is a fulcrum position over here. ये मैकेनिकल वाला है, ये पुराना वाला आजकल ऐसा होता नहीं, बट दिस फॉर अंडरस्टैंडिंग ये ऐसा एयर नीचे गया, ये डीप्रेशराइज हो गया. जैसे ये डीप्रेशराइज हो गया, ये स्प्रिंग से ये ऊपर चले गया. स्प्रिंग से ऊपर चले गया तो ऑटोमेटिक एयर स्टार्टिंग वाल्व allows the air to go from here to here, and it will allow the air to go from here right to your main unit where the engine is there. Now it is going on to the starting air distributor. Air injecting is not happening because the air starting valve pilot line is not yet satisfied. Okay. Now the air comes up here, and then what will happen? It will first push the distributor, the compress the spring, and it will fall onto the base circle onto the starting position in the profile. It happens. And as soon as it comes, number 4 is already in the starting position. So the air goes from here, right on top, and now your air is injected in the unit. Okay. Now what happens is the engine starts turning on air, and this is vented initially. Okay. Engine starts turning on air. This is showing the clockwise movement. And now the distributor turns and it will basically block the distributor. As soon as it blocks, the air is basically going to come out here and it's going to vent, and now the distributor is going to be depressurized along with the main air line. Okay. The main air pilot line is being depressurized, so the valve will shut immediately. That is right. There's this one. And then again, when the engine is stopped, okay, it goes again to the stop position. The pilot valve is energized in this case, and it is shutting the signal. And now this line, which is not be able to go to the distributor, either will be this signal to the main end. This is the idea. Okay. And again, now you're going into the fuel running. You will come to the fuel running later. And now you can actually go into the fuel run. Basically, you can increase your pay of the fuel, and you can go ahead. That is right. The movement. So this is the process of the air starting valve, how it operates in the air starting. Okay, how the automatic air starting valve operates. Is it okay? Is it understood?
Yes,
This,
yes, sir.
the same diagram which I've just visually made into a sheet like this. Yeah. This is just for understanding. because ये सब component आजकल नहीं होता है. ये पायलट वॉल्व का भी दो ऑपरेशन होता है कि एक डीप प्रेशराइजेशन में ओपन होता है, एक होता है एक टाइप होता है जिसमें प्रेशराइजेशन में ओपन होता है, डिपेंड ऑन द मेकर. ठीक है, उसमें होता है, बट आजकल वो है ही नहीं. यू डोंट हैव दैट आइडिया. So that completes our air starting system. Okay. Now next part is about reversing. We'll cover that. All right. We will study both the principles of reversing and reverse motion together. So here you have a timing cycle for a four-stroke engine, which is reversing. Basic idea है कि आपका timing cycle है showing the ahead running and external. Okay, 1, 2, 3, 4, 5, 6 are the positions that you have got exhaust valve open, close, fuel injection start, stop, air inlet valve open and close. Okay, that is the idea. In ahead and external. Similarly, now you have a two-stroke also. I'm not showing the two-stroke also. It is the four-stroke in hand. Okay. Now, reversing system must include means of turning the engine in the opposite direction by compressed air. The fuel injection system should adopt for reversing, turning, running, and conditions which should be satisfied are change in the sequence of the starting air admixture, okay, and reposition of the camshaft for reversing, running sequence. Basically, the camshaft should be reversed and the air starting should be reversed. Okay. So exhaust valve should not be done. So fuel injection is done and this thing is done. Now, reversing system of the engine involves reposition of the starting air distribution, fuel injection time, intake call, exhaust time. Now, exhaust valve cam, some of them are reversed, not all of them. In relation to the crankshaft, some of them are reversed. Okay. So, some of them are reversed. Nowadays, most of the engines are not reversed exhaust valve. ये पुराना एक ये था. I have to change this. Not nowadays exhaust cam is not reversed. Okay. So the engine can be set to a firing sequence with reverse running direction. Okay. Now, four-stroke runnings, how is the reversing done? Tell me, guys. Four-stroke में reversing कैसे करते हैं? अगर आप air starting से reversing कर रहे हो, तो how is the reversing done?
तो फोर स्ट्रोक में रिवर्सिंग क्यों करेंगे? डीजी तो नहीं करते ना रिवर्सिंग.
See, generator में नहीं, but four-stroke engines, some of them are propulsion engines. So ये आपका वार्ड सर का क्वेश्चन है, how do you reverse the four-stroke engine and why would you want to reverse? Okay. So there are 2-3 methods of reversing the four-stroke engine. One method is actually putting a gearbox in middle and gearbox को आपने ratio change करके आप उसको reverse. Okay, वैसा है. दूसरा मेथड है कि सीपीपी लगा तो इंजन को रिवर्स करने की जरूरत नहीं है. वो आपका इंजन आपका शाफ्ट क्या बोलते हैं, आपका प्रोपेलर का जो पिच है वो चेंज हो जाएगा तो रिवर्सिंग करने की जरूरत नहीं. तीसरा मेथड है कि इंजन को ही आप बाई डायरेक्शनल रोटेशन कराते हैं. ठीक है, कि नाउ दिस इंजन कैन बी ऑपरेटेड बोथ इन अहेड एंड एस्टर. So you are thinking always four strokes as your propulsion engines or your power generation engines, but there are also four stroke engines which are reversing for your propulsion. ठीक है, तो वहाँ पे डायरेक्ट कनेक्टेड क्रैंकशाफ्ट के साथ में आपका प्रोपेलर होता है. देयर इज नो गियर बॉक्स. ठीक है, या गियर बॉक्स भी होगा तो गियर बॉक्स में भी रिवर्सिंग का ये प्रोबेबिलिटी नहीं है. ठीक है, सो यू हैव टू रिवर्स द मेथड ऑफ रिवर्सिंग फॉर द कैमशाफ्ट फॉर योर four-stroke engine is very simple. We just see this. So moving camshaft actually, there are two separate sets of cams which are mounted side by side. Correct set of cams are engaged with the follower by actual moving of the camshaft with servo. So basically a servo motor is there, basically a pneumatic cylinder or hydraulic cylinder which is operating a set of movements of the entire camshaft. Okay. That is the idea. So ये जो आपका जो camshaft है, entire camshaft is going to be moved. Now exhaust valve cam moving. अच्छा, this was actually talking about the four-stroke. That's why I just talking about the exhaust valve cam. That's why I realized. So intake valve, इसलिए intake valve cam बोलते हैं. Intake valve तो मैं I didn't realize कि intake valve cam, exhaust valve cam is talking about the four-stroke. तो इसलिए four-stroke में तो करते ही हैं. Four-stroke में तो आपको करना ही पड़ता है. अगर आप रिवर्सिंग कर रहे हो तो intake valve exhaust cam को भी करना पड़ेगा. तो आपका इंजन का लॉन्ग टाइम के टू स्ट्रोक में नहीं होता. ठीक है, माय मिस्टेक वाज दैट आई थॉट इज टॉकिंग अबाउट टू स्ट्रोक. ये फोर स्ट्रोक की बात है. सो नाउ फोर स्ट्रोक के अंदर कैसा होता है? वेरी सिंपल सिस्टम. यू सी, यू हैव एन अहेड कैम, एस्टर्न कैम, and again you got one ahead cam and extern cam over here. So this is your exhaust cams and these are your fuel cams. Okay, now exhaust and fuel is there and you will have similar this thing control over here. तो ये आपका pneumatic cylinder which is a servo motor. So the servo motor can be operated by this pneumatic cylinder moving entirely actually up and behind. And ये आपका it is basically connected to your shaft also, shafting system, getting a feedback from that. Okay. This is the way this cam is there. ये जो cam है ऐसा होता है. Two separate profiles, one ahead profile, astern profile on the same body. Okay. And this is a mechanical system linkage where you can get a servo cylinder which is moving the entire servo cylinder ahead or behind, and when it moves it ahead or behind by linkages, it is connected to the shaft also. Okay, and this is acts like a feedback, and then here is basically connecting to the camshaft. Camshaft को ये पूरा का पूरा drive कर move करेगा actually, and here this is the connection from your crankshaft, and this is your camshaft. Okay, the entire thing moves ahead and astern, and when that happens, the exhaust and the cams are moved. So this is how it is actually there. Okay, you have an exhaust cam and fuel cam, head astern, head astern. Okay, इनलेट काम का भी होगा. इनलेट कैम का दिखाया नहीं है, बेसिकली इनलेट कैम का भी सिमिलर. ठीक है. So this is the servo cylinder. Now servo cylinder is in ahead position. तो ये इसको पूरा अंदर दबाया हुआ है. When it is pushed on the right side, the engine is always turning in the head direction. When it is on the exhaust cam and the fuel cams. Okay. Inlet cam का भी होगा, inlet cam का दिखाया. Okay, just because it becomes a little bit much more difference. So now when you want to move it from ahead to astern, you start the air pushing it from left side of the servo cylinder and removing it from other side. Hydraulic oil is not air. In this thing it is a hydraulic oil. In the previous one it was a pneumatic cylinder. यहाँ पे hydraulic. So hydraulic oil is not. And as it moves from the head to the astern profile, and there is a very smooth transition. As you see here, there is a very smooth transition. So there is an incline. So basically, from the head to the astern profile, there is a smooth transition, incline or decline. On one side there is the incline, one side there is the decline. Okay, and basically that is what is allowing the transmission from the head to astern profile. So two separate cams for the exhaust and the fuel and the inlet. Okay, that is the idea. So then the entire thing is basically moving from ahead to astern. Astern, so we want to go to ahead, go ahead. Yeah. That is the horizontal shifting or axial shifting of the cam or camshaft. Here the entire camshaft is moving. That's why it is the reversing by the axial shifting of the camshaft. Now, as I was saying, some of the two-stroke engines, like your RTA, use for the starting a distributor, they have got a vertical system. I'll show that also. It is study starting a distributor for the Sulzer. इसमें दिखा दूंगा. So idea क्या है, ये head astern में जाता है. Now, is it understood how it operates?
Yes, yes.
Now let us talk about your two strokes. This is a two-stroke timing diagram. Ahead astern. Again, this is the TDC. Your fuel valve opening, fuel valve closing, exhaust valve opening and exhaust valve closing is up here. Okay, at number 6, right? Number 1. And number 6 is basically a scavenge photo connectors. ये post scavenging है, ये आपका inlet valve है, वो सब है. It is the idea. Now the idea being is that they is given the both the timing as per the ahead and astern. Now there in the as we saw that for reversing method of reversing, either you have got the lost motion clutch for the Sulzer, okay, which turns the camshaft in relation to the crankshaft, and then for man bend of your fuel pump, they're using shifting roller point of contact. Okay, so lost motion clutch camshaft, where there is one set of symmetrical cam in use for reversing. So basically, एक ही set of cam है. Only thing is that the cam angle in relation to crankshaft is changed. Okay, the lost motion clutch turns the camshaft in a new required position. Rotation of the camshaft is independent of the rotation of the crankshaft. Lost motion of the reversing angle is also so chosen that the same fuel timing is maintained in both ahead and astern. That is for your Sulzer engines. Other idea is moving fuel pump roller guide point of contact. So one set of
सर जब ये लॉस्ट मोशन क्लच फंक्शन में होती है, तो कैम शाफ्ट का जो एंड जो ड्राइविंग एंड है वो डिसेंगेज हो जाता है क्या?
नहीं, वो मैं दिखाऊंगा आपको how it is. It is having one internal gear, one beveling is there, and a second gear. Not beveling. There is the internal and external gearing. I will show you when we come there. I will just cover it. तो वो दिख जाएगा आपको कैसे वो रोलर पॉइंट ऑफ कांटेक्ट है, ये सब दिखाऊंगा. So लॉस मोशन क्लच के अंदर थोड़ा डिफरेंट है देन योर फ्यूल पंप पॉइंट ऑफ कांटेक्ट. ठीक है, ये वाला काफी सिंपल है. मूविंग फ्यूल पंप रोलर गाइड सिंग where there is one symmetrical cam used for reversing. Pneumatic actuators are used for correct positioning of fuel pump. और ये exactly क्या है आपको दिखा दूंगा. Actuator मतलब basically there are what you call cylinders and everything which is moving your entire follower which is there on the bottom of your fuel pump. Yeah. उसका point of contact change करता है. Now there is basically a reversing servo motor, okay, for the lost motion clutch. Okay, it consists of pair of vanes fitted in a camshaft which move between another pair of vanes fitted within the gear of the wheel rim. Just understand this and we'll see what I mean. Okay, by applying lube oil pressure on opposite pairs of vanes, the camshaft is turned relative to the gear wheel and the crankshaft. The reversing control valve controls the lube oil flow in and out of the servo motor. So उसको servo motor को control एक separate control mechanism है. What is by solenoid valve. The relative motion between the camshaft and crankshaft, known as the loss motion, changes the timing of the fuel pump and the starting air distributor for ahead and astern. Okay, so starting air distributor see very first they had both the starting air distributor and the fuel pump for RLB RTA. Then later on, when they had the RTA, the new type of fuel pump in RTA, the newer one, what they did, they only did the fuel pump by this and starting a distributor for the vertical shifting of the cam and camshaft. The vertical shifting of the camshaft, not the horizontal shifting. ठीक है, जब भी हमने horizontal shifting वैसा नहीं, but basically vertical shifting. तो दिखाऊंगा आपको जब मैं starting a distributor of Sulzer दिखाऊंगा. Now idea क्या है कि इसके अंदर ऐसा होगा. So idea see, now this is the gear drive coming from the ahead and this is the once I आपको बेटा image of this. नहीं वही वाला image है. Let's see this one. Right. So here the engine is operating in ahead direction. So the intermediate this is a gear drive, right? For your Sulzer. Okay, there is the gear. Now what is happening is this is your lost motion clutch, the pink one, okay, and this the greenish one. The entire thing, which is inside the rim of your final camshaft gear drive, उसके अंदर hollow है और उसके अंदर ये है. And the camshaft is connected to this. Camshaft is connected to this pink thing. Okay. So what happens is once the ahead signal is going, this thing is going in the opposite direction, and you're getting the same ahead direction. ठीक है, ये clockwise घूम रहा है, ये भी clockwise घूम रहा है. Shaft भी आपका जो connected है आपका to the camshaft to this lost motion clutch. ठीक है, this pink part, the camshaft is connected to this pink part. ठीक है, वो भी यही side पे है. Now there is no motion in this, it is operating. But suppose I give by a servo cylinder, I give a signal and I alter the signal in this manner. Now what is happening is the entire camshaft has traveled this degree, right from this ahead position to the astern position. It has traveled some degrees, right? So this amount of travel allows the changing of the profile for going symmetrical. There is one cam only, and that same cam, the point of contact of the ruler is now basically shifted. So what it does, basically, so this thing basically changes your. Just give me a second. All right. As this flapper moves, this lost motion that the flapper moves from ahead to astern. Now the engine is stopped in this condition. It cannot be done in the running condition. Engine is stopped, and then the engine is started. Now when the engine is started, the engine will operate in the astern motion. Because why? The relationship of the camshaft has changed by a particular angle. Okay. So the flapper has moved from the ahead position to the astern position. So अगर मैं इसको annotate करता हूँ, So initially your angle is here, your camshaft is here. Now when you are operating your this thing, it is moving from an angle. So now entirely your new angle is basically this is the thing. This thing, is here. So entire what do you call uh, the entire camshaft has traveled this much distance. Entire camshaft is able to travel basically from here to here. So this angle is the reversing angle which reverses the entire engine, and now when the engine starts on the air, it will start in the external. So ये जो आपका angle है ये shift हो गया. So now whatever is the say एक ही cam है. Now the entire engine is being reversed. ठीक है. And you are having the I will show the cam के क्या है इसका कौन सा cam है ये सब देखेंगे आगे. ठीक है. This is right. Is this understood?
Yes, yes.
How the lost motion clutch works. So lost motion clutch में finally आपका जो अंशुल आपका जो question था, is it satisfied कि this is always in contact with the gear, ये नहीं move करता. Gear के अंदर एक hollow part है जिसके अंदर एक pneumatic hydraulic cylinder है जिसके अंदर से flapper and everything moves. ठीक है. So what is connected to the camshaft is basically in this pink one. ठीक है. Is that okay, अंशुल? ठीक है. अनंत आपको समझ रहे हैं जो मैं बता रहा हूँ?
Yes, sir. Yes, sir.
Yeah. So how this moves in the external head is the idea. So idea है कि you're able to transmit this angle and you're able to move it through there. That is right. So now one second. Right. So this is a lost motion clutch. Okay. So lost motion clutch is basically cam is moved by 55 to 55 110 degrees. तो जो angle बताया था 110 degrees से shift हो गया है. Okay. So entire camshaft is basically moving from ahead to astern. Okay, by 110 degrees. In a reversing motion, servo motor fitted in the camshaft using a single symmetrical cam. It turns the camshaft to a definite angle with about 110 degrees. Okay, with the firing angle, which changes the firing angle of the engine. It repositions the fuel cam and a distributor cam to a new sequence of the starting of the engine. Reversing engine is chosen at the same fuel timing as obtained in both astern and ahead. मतलब symmetrical cam है तो आपका कोई problem नहीं आ गया having the again this thing. ठीक है. So as I said initially, you had the this for both the starting air distributor as well as the fuel pump. Later on in RTA, they decided that we want the starting air distributor to be independent of this. The lost motion clutch was only connected to the fuel pump, and fuel pump was reversing by this, and there was a separate connection by a vertical shaft, by vertical movement of the starting air distributor cam. ठीक है, I'll show that. So ये वही दिखा रहा है, देखो ये वही lost motion clutch दिखा रहा है. The fuel pump roller now will be initially you're moving it to this 110 degrees. पहला आपका TDC के पहले यहाँ पे आता था, अभी आप TDC के पहले ये साइड में, आपका हेड में पहले यहाँ पे था, अभी आपका इंजेक्शन एस्टर में यहाँ पे. And in the single move from the entirely operated. Okay. So dwell angle in the puncture is head before return, and basically this dwell angle is 30 degrees, 10 degrees. Okay. So this is the idea of the how that is onto your this thing is there. Okay. I will show you the actual cam and everything of this thing in a later point. Okay. So reversing servo motor. Let me talk about this air starting distributor servo motor जो है बात कर रहा हूँ. देखो ये एक्चुअली लॉस्ट मोशन क्लच ऐसा दिखता है. एक्चुअली जब बात करते हैं ना, इट लुक्स लाइक दिस. इट लुक्स लाइक दिस एंटायरली फ्रॉम आउटसाइड यू सी इट लाइक दिस, एंड दिस इज द लॉस्ट मोशन क्लच का ये वाला पार्ट इज दैट पिंक पार्ट व्हिच वी सॉ. ठीक है, द फ्लैपर व्हिच इज मूविंग एंटायरली लाइक दिस. ये जो पार्ट है, एंड दिस इज बेसिकली द कैम व्हिच इज द फ्यूल कैम. कैम एंड कैम शॉट हटिएगा, ये रिवर्सिंग सर्विस है. और जो हमने जो फोर स्ट्रोक का रिवर्सिंग का देखा था सिलेंडर, वो ऐसा दिखता है. ठीक है, horizontal moving shifting का ऐसा है, ठीक है. You have got the few cam, then you have got the different cam starting in distributor as well as the immediate exhaust cam. 3 cam है यहाँ पे, ठीक है, moving ahead and behind. तो ये पूरा एक engine का है यहाँ पे बीच में. That is the idea. That is the idea. They've only shown the fuel here, otherwise का दिखाया. This is the servo cylinder which is moving it in and out. Just give me a second. As I was saying that some of them are having a horizontal shifting or a vertical shifting of the cam and the camshaft. तो ये ऐसा हॉरिजॉन्टल शिफ्टिंग का आपका मैन बीडब्ल्यू का स्टार्टिंग एंड डिस्ट्रीब्यूटर का आइडिया था. What they had is they had an air clutch, similar manner what we saw just now. Only thing is that you are moving the entire starting and distributor moving horizontal and you got two separate profiles. जैसे हमने देखा था ना एक जिसमें दो profiles था. So entire thing was going to be moved by air clutch horizontally like this in a manner, and you are moving it either from the head cam to the stern cam. And again there was a transition between the two cams where you had it. Okay, this was your starting and distributor with two axial shift of the camshaft. Okay, that was the idea. Where you had a air clutch and it was doing it from air to stern, and in the air clutch phase, you've got manual method also to reverse it. Okay, this is like a very old MC engine. Okay, MC engine idea. No longer you're having this type of an idea. And then, as I was saying, Salzar ka vertical shifting for the starting air distributor है. Salzar का RTA का starting air distributor का vertical shifting है similar air clutch से, but now there's a vertical shifting. एक ahead clutch है, एक ahead cam है, stern cam है, दोनों vertical shifting. You have it like this, like a vertical shifting for the starting air distributor for the this fuel pump is by your by loss function clutch. Okay, there is a bevel gearing at the end of the camshaft which is connecting to this thing. I just show you this. So you see here, this is a Salzar starting at distributor. Here you have got the two cam profiles, ahead and stern, and this vertical drive shaft can be moved by a servo cylinder again. Ahead signal, stern signal, it will move this up and down. Okay, and that is basically the starting at distributor is going to be moving the drive of the वर्टिकल स्टार्टिंग एंड डिस्ट्रीब्यूटर ऐसा है. ठीक है, तो ये आपका सल्जर का आरटीए का स्टार्टिंग एंड डिस्ट्रीब्यूटर. ठीक है, इसको भी कंट्रोल यहाँ से आता है 30 बार सिग्नल, और ये आपका कट ऑफ वॉल्व है अगर आपको इमरजेंसी कट ऑफ करना है, और ये एयर सिग्नल वही आ रहा है जैसा वेंट कर रहा है, और ये आपका वो जो बाकी सब सेम ऑपरेशन सेम है, ओनली वर्टिकल शिफ्टिंग. ठीक है, वर्टिकल शिफ्टिंग और स्टार्टिंग एंड डिस्ट्रीब्यूटर. Now, for the Sulzer starting air valve, two are different here. Air starting valve. Here you got a starting air valve of Sulzer. Again, the balance piston has got nothing, but here you see inside the main operating piston there is this O-ring. Okay. See here also you got O-ring. Okay. तो इसमें यहाँ पे भी O-ring दिया है, यहाँ पे भी दिया, और यहाँ पे ऊपर भी दिया, सब जगह पे O-ring gasket दिया. C245. Do I have the parts list? No, I don't have the parts list. Okay, C245 piston ring for starting air valve, piston ring for starting air valve, piston ring for starting air valve. So they are having piston rings over here. Okay. So basically, again, you've got piston rings over here. You have bigger sealing against it over here. And body वाला तो O-ring here C7249 7249 O-ring housing. यहाँ पे piston rings. Okay, piston ring, piston ring, piston ring, and nothing over here. 27143 is spindle guide starting here. This is the balance piston basically. So spindle guide. एंड बाकी सब तो सिमिलर ही है, और ये इसका ऑपरेशन करना क्या है, एवरीथिंग इज देयर स्प्रिंग के बीच में। ओके, ये स्टार्टिंग एयर वॉल्व आरटीए का था। Okay. Now, what is remaining is starting air control system for uh, your main engine, man point of view. एक काम करेंगे, tomorrow we will start with that. Man point of view का आपको cams भी दिखा देंगे, and then we will go to the motions of what is there in this horizontal. Or let's just finish it today. Just give me a second. और 5-10 मिनट में खत्म हो जाएगा, फिर वो मेरा हेडेक खत्म होगा, फिर वो आपका सिमुलेट करता है। So what you have here you have the horizontal shifting of the roller point of contact for man point of view starting air distributor. तो आइडिया क्या है कि ये स्टार्टिंग एयर डिस्ट्रीब्यूटर चल रहा है, ठीक है, अहेड और वेस्टर्न में। ये इसके ऊपर आपके फ्यूल पंप का वो आपका जो क्या बोलते हैं, जो आपका स्प्रिंग है फ्यूल पंप का है, और आपका फ्यूल पंप का प्लंजर इसके ऊपर। What you have down here is the follower for the entire this thing, क्या बोलते हैं आपका जो स्टार्टिंग एयर, सॉरी, फॉर योर फ्यूल पंप का आपका जो follower, ठीक है। तो your roller point of contact will be done. So when you are having Estern, the same cam is same. What is happening is this entire pneumatic cylinder is going from ahead to Estern, moving this from one position to the other side, ठीक है। When we see the cams of this, we will understand what is the angle. But basically क्या करता है, देखो, you can either do one thing, जैसे लॉस्ट मोशन क्लच में 110 डिग्री में यहाँ से यहाँ पे घुमा दिया, मीन्स कैम को घुमा दिया। यहाँ पे क्या कर रहे हो आप, सीधा इसको आप 30 डिग्री से शिफ्ट कर, ठीक है। जैसे लॉस्ट मोशन क्लच में क्या किया था आपने, ये आपने यहाँ से इधर से आपने ऐसे करके आपके एस्पेक्ट में इतना घुमा दिया, ठीक है। when you turn your this thing, so entire this thing is moved from 110 degrees from ahead to astern. You did not travel this distance. Okay, why you did this distance? Because in your सर्जर के अंदर ये जो कैम एंगल है बहुत लार्ज होता है, ठीक है। सी दिस इट्स अबाउट maybe 80 angle, 80 degree is there is the angle here. What is the angle is here is up to only 30 degrees between the head and stern. तो ये 30 degrees shift होता है from one position to another position, and it just moves from head to stern. And when it does that, it will basically, by pneumatic cylinder it is operating, and it is basically doing the reversing for the shifting the fuel pump roller point of contact in relationship to the cam. So cam does not shift the roller point of contact. वो जो आपने सर्जर में किया था, टोटल कैम को ही शिफ्ट कर दिया था 110 डिग्री से। यू विल सी द कैम एंगल एंड एवरीथिंग, और अब देखेंगे हम लोग। एंड आइडिया क्या है, यहाँ पे ये लोग ने दे शिफ्टेड द रोलर पॉइंट ऑफ कॉन्टैक्ट एंड दे शिफ्टेड इट बाय 30 डिग्रीज टू ट्रैवल द सेम एंगल। इंस्टेड ऑफ ट्रैवलिंग 110 डिग्रीज जैसे उसने ट्रैवल किया है, यहाँ पे 30 डिग्रीज शिफ्ट, ठीक है। तो वो 110 भी इज नॉट अ एग्जैक्ट एंगल, तो जब देखेंगे तो 80, 90, 110 ही है। तो वो आइडिया वही है, 110 ही है इसका। इसका जो आइडिया है, इसे 30 डिग्री से वो चेंज करता है, ठीक है। दिस इज आइडिया। You have a pneumatic cylinder and you have got a motion of the cylinder. It goes from left to right, right to left, and you see that. Okay, that is right for the shifting of the roller point. So what is doing here? Now the roller of the fuel pump is connected to the linkages of the reversing cylinder, and upon giving the astern movement, head decline. Upon giving the astern movement, what will come from here? Okay, the cylinder and the linkages shall move the roller to the astern position, like you see here. Now they move it to the astern. हेड पोजीशन पे था, अभी वो एस्टर्न पोजीशन, ये हेड पोजीशन में था, अभी वो एस्टर्न पोजीशन, okay। And this roller point of contact shifts the angle by an angle of to 30 degrees. This action is preferred rather than moving the entire cam angle. ये total cam angle था 280 डिग्री यहाँ पर इस साइड, ठीक है। So it becomes easier to move this from 280 degrees or rather than from here to here, you're only moving 30 degrees. We'll study the cams tomorrow. And we will actually study the entire starting year certificate, ठीक है। तो ये इंटरलॉक्स हमने देख लिया है, एंड सेफ्टी फीचर्स कटआउट ये है, ओवर स्पीड कटआउट, लो प्रेशर कटआउट, और भी हैं, ये सब जस्ट वेरी फ्यू ऑफ देम आर देयर। इंटरलॉक्स एंड ब्लॉकिंग डिवाइसेस ये सब हैं, स्टार्टिंग ईयर इंटरलॉक, रिवर्सिंग इंटरलॉक, ब्लॉकिंग डिवाइसेस, मैकेनिकल, न्यूमेटिकल, इलेक्ट्रिकल, हाइड्रोलिक टाइप टू मेक द इंजन सेफ, okay। These are all the things. Now what is remaining is actually the line diagram which is incorporating everything. वो कल हम देखेंगे and we will see the simulators for man BW. Actually, before starting that, we will first see the cams. Okay, your fuel cam of fuel cam angles and everything of your man BW and fuel cam angles of your starting edge for your starting edge distributor and for your सर्जर का जो फ्यूल की कैम और उसका वायरिंग, ठीक है, तो इसीलिए अच्छा कल तो क्लास नहीं है हमारा, तो अभी कल फ्राइडे है, कल सैटरडे है, 30 तो संडे को क्लास रखते हैं, ठीक है, संडे नहीं आज सैटरडे को नहीं, आज फ्राइडे है, कल 31st है, तो 1st तारीख को संडे को कैन वी कीप अ क्लास संडे इवनिंग सेम टाइम?
Sure, sir.
Anshul and Anant, if you are interested, you can join at ठीक है, तो ना वही
Yes, sir.
9:30 हम लोग join, ठीक है,
ठीक है सर.
ठीक है, तो वो we will continue with this जो हमारा जो स्टार्टिंग है डिस्ट्रीब्यूटर हो गया, ये सब हो गया, अभी हमारा सिमुलेटर्स बाकी है, तो I have a simulator on Salzar, I have a simulator on Man BW, then I also have a simulator of MEC, वो तीनों हम लोग कर देंगे before we start with the cams and the actual the line diagram देख लेंगे और फिर हम लोग ये कंप्लीट करेंगे, ठीक है
सर कल का जो शेड्यूल आया है फिर उसका वो नहीं है ना सही, वो कैंसिल्ड है
शेड्यूल, आई एम नॉट सीइंग
वो एक शेड्यूल डाल दिया है ग्रुप पे सर कल के लिए भी.
आई टेल व्हाट इज ही पुट टू वो शेड्यूल फॉर सैटरडे, नहीं मेरा नहीं होगा, मेरा नहीं होगा, आई विल नॉट डू इट कल you are still having the same schedule, you're traveling?
Yes sir, yes sir.
ठीक है, then no point one of the guys is not there, मैं भी थोड़ा छुट्टी दे देता हूँ, आई टॉक टू हिम, ठीक है, आज वैसे भी हमने आधा घंटा एक्स्ट्रा कर लिया है, 2.5 hours कर लिया, थोड़ा सा वैसे ही कॉम्पनसेट हो गया. Tomorrow we will not have, we will meet straight away on the new year, ठीक है, चलो guys, happy new year in advance, ठीक है,
Wish you the same sir.
yeah,
Yes
safe,
sir, wish you the same.
yeah, safe travels for you guys who are traveling home or wherever, ठीक है, be safe and we will meet you in the new year, ठीक है, चलो guys, good.
Thank you sir.
Thank you sir. Good night.